So let's start with the chapter Chemical Kinetics. One question, are you done with the Chemical Kinetics chapter yesterday which we did? Just say yes or no. I just want that. Just say yes or no in the chat. Are you done with this particular chapter? Are you done with this particular chapter? Yeah? If you remember, we already did a lot of questions from Chemical Kinetics yesterday, and today, the other types of the questions which can be asked, let's kill them. Let's kill them. Perfect, guys. So let's get going then. Let's get started with the first question of the chapter Chemical Kinetics, which is on your screen now. A very simple and basic question, and I believe everyone among you can solve this particular question. Give it a try. Let me know its answer in the comment section quickly. I mean, in the chats quickly. Let me know its answer in the chats quickly. Till then, I'm going to write the reaction again, what is given to us. BrO3 negative plus 5 times Br negative plus 6 times H positive. It gives 3 times Br2 plus 3 times H2O. This is the reaction that's given to us, and the reaction is given in the balanced format. Well, I can see majority of the students are coming up with option D. Let's exactly get to know what is going to be the correct answer of this particular question. My dear students, if I want to write the rate, expression, I'll be starting with BrO3 negative, which is a reactant. If it is the reactant, I'll start with minus sign. 1 divided by stoichiometric option is 1, right? Then it's change in the concentration of BrO3 negative divided by time taken is equal. Write the rate in terms of Br negative. In terms of Br negative, it is minus 1 by stoichiometric coefficient. Change in the concentration of Br negative divided by time taken. Perfect. Write the rate in terms of Br2. Since it is the product, so start with plus sign. 1 divided by stoichiometric coefficient. Change in the concentration of Br2 divided by time taken. Right? You can write in terms of water as well. Well, as per the question, we have to relate two things. We have to relate Br2 and Br negative. We have to relate Br2 and Br negative. My dear students, if you relate these two terms, if you take 3 here, it becomes minus 3 divided by 5. D of Br negative divided by dt is equal to D of Br2, change in the concentration of Br2 divided by time interval. Do you see any option matching this? Do you see any option matching here? Is there any option matching, people? D of Br2 divided by dt is equal to minus 3 divided by 5. D of Br negative divided by dt. I believe option D is the correct answer of this particular question. If this question is clear, say yes or no in the chats. Yeah? Tahir is saying he did this question early in the morning. That's great. Perfect. So absolutely it's option D. Absolutely it's option D, which is going to be the correct answer of our first question. Number 1. Do you know, in your NEET 2019, the question was asked of the similar type? Similar type question was asked. Can you quickly let me know what is going to be the answer of this question? In the chats. In the chats. Quickly. Quickly, guys. A lot of people are unable to join Telegram. Let me write the Telegram link again. t.me/WASSIMSIRCHEM. You can join this. Majority is coming up with option C. Majority is coming up with option C. So let's get to know exactly what is going to be the correct answer of this particular question. My dear students, again, you'll be doing the same thing. You are given with a balanced chemical equation. Write its rate. Write its differential form. Write its differential form. R is equal to. If I write the rate in terms of N2, you'll start with minus sign. Then you write change in the concentration of N2 divided by time interval dt is also equal to. In terms of H2, it's going to be minus 1 divided by 3. Change in the concentration of H2 divided by time interval. In terms of NH3, NH3 is a product. So start with plus sign. 1 divided by 2, change in the concentration of NH3 divided by time interval dt. Now, as per the question, you have to relate what? What is going to be the correct answer now? If you see the options, my dear students, What is going to be the correct answer? What is going to be the correct answer? Quickly, if you see the options. People are saying option C. Is that? Is it going to be option C? Option C cannot be the one, right? Because this is minus here. This is minus here and this is plus here. Or yes, option C only, right? So this term and this term you can relate. So option C, is it matching? Minus dN2 divided by dt is equal to plus 1 by 2 d of NH3 divided by dt. So it's absolutely option C which is going to be the correct answer of this particular question. My dear students, you can understand what type of questions are asked in your NEET examination, right? I'm moving ahead. I am moving ahead. I am moving ahead. I am moving ahead. Just a second. Okay. Can you give this question a try? The decomposition of NH3 on platinum surface is a zero order reaction. Decomposition of NH3 means the reaction will be 2 times NH3. NH3 decomposes and it gives your N2 gas plus 3 times H2 gas. This is the reaction. As per the question, it's mentioning that it is a zero order reaction. It is a zero order reaction. The rate of production means formation. The rate of formation of N2 and H2 are respectively. Rate constant is also given to us. Rate constant is also given to us. What do you think about this particular question? What do you think about this particular question? Can you give this question a try? Quick. Be very quick. Be very quick, people. Be very quick. What do you think? People are saying option B. Is that? Should I go with option B? People are saying option B. My dear students, look at this particular question. The question is mentioning that it's a zero order reaction. If it is a zero order reaction, can you write its rate law? Its rate law is equal to R is equal to K, concentration of NH3 raised to the power what? Raised to the power 0, because it's a zero order reaction. So as per this particular equation, anything raised to power 0 is 1. So you got to know your rate is equal to K. This is the first thing. R is equal to K, which I got. This is the first thing which I got here. R is equal to K. Number 1. Number 2. If you write the differential form of rate here, I can say R is equal minus 1 divided by 2, change in the concentration of NH3 divided by time taken. Perfect. You can write the rate in terms of N2 as well, right? It's going to be plus 1 divided by 1, change in the concentration of N2 divided by time interval. Similarly, you can write the rate in terms of H2 as well. It's going to be plus 1 divided by 3, change in the concentration of H2 divided by time interval. Correct? All these terms also are going to give you the rate of the reaction. They are giving you the rate of the reaction. Perfect. They are giving you the rate of the reaction. Now, people, what are we supposed to calculate? We are supposed to calculate the rate of formation of N2. Perfect. All these terms are giving you rate. And this term is also giving you rate. R is equal to K, R is equal to this. So I can equate all these terms to K. Because R is equal to K, R is equal to this, R is equal to this, R is equal to this. So R has to be equal to K as well. Perfect. So rate of formation of N2. My dear students, if you relate this term and this term, I can say plus d of N2 divided by dt. Plus d of N2 divided by dt has to be equal to what? It has to be equal to K. And what is K? K is given to me as per the question, which is 2.5 into 10 raised power minus 4. So it is 2.5 into 10 raised power minus 4. And it's going to be moles, liter inverse, second inverse. What do you call this particular term as? This particular term you call as the rate of formation of N2. That was the first thing which I was supposed to calculate. Rate of formation of N2. Rate of formation of N2 we got. Rate of formation of N2 we got. What is the second thing? Rate of formation of H2. Now do one thing. Relate this H2 term with this K, right? What can I conclude? I can say dH2 divided by dt is equal to 3 times K. dH2 divided by dt is equal to what? It is equal to 3 times your K, right? So it's going to be 3 multiplied by 2.5 into 10 raised power minus 4 moles liter inverse, second inverse. Correct? Correct, people? So This is going to be 7.5 into 10 raised per minus 4. 7.5 into 10 raised per minus 4. So it has to be option B, which has to be the correct answer of this question. Right? I believe this sort of a question you can solve from now on. Right? Someone is saying my NEET score is watching right now. How many people are watching? 700 something? Oh, nice. Good. Good. But make sure it's not more than 720. Make sure it's not more than 720. Is this particular question clear, people? So whenever you see this sort of a question, this is the approach which you'll be using to solve the question. Right? Let me move ahead. Let me move ahead. Basically, here the options we do not need. You are given with the reaction XA plus YB gives ZC. Some data is given. Choose the correct statement among the following. So basically, you have to get the value of X, you have to get the value of Y, right? Or get the ratio of X is to Y is to Z. This is the question. Get the ratio of X is to Y is to Z. This is your question. You need to get the ratio of X is to Y is to Z, where X, Y, and Z, these are the stoichiometric coefficients of your reactants and products. Can you give it a try? Can you give it a try, people? Can you give it a try? My dear students, the reaction that's given to us, you can write its differential form. It will be, if you look at the reaction, write the rate in terms of A. It has to be minus 1 divided by X, change in the concentration of A divided by dt. In terms of Y, it has to be minus 1 divided by Y, change in the concentration of B divided by dt. In terms of Z, it has to be plus 1 divided by Z, change in the concentration of C divided by dt. Agreed? This is one equation. This is one equation. Now, as per the question is concerned, we are given with some other things as well. We are given with minus d of A divided by dt. Minus d of A divided by dt is equal to minus d of B divided by dt. Minus d of B divided by dt, which is equal to 1.5 times d of C divided by dt. Correct? This is something which is given to us as per the question. This is the given data. This is the given data. Now, guys, if you look carefully, can I do one thing? If I remove this 1.5 from here, and if I want to write it as 1 divided by 1 by 1.5, will it make a difference? That 1.5 again goes up. It won't make a difference. Now, if you compare these two equations, this is minus 1 by 1. This is minus 1 by 1. This is 1 divided by 1 by 0.5. Correct? Right? If you compare them, X is to Y is to Z, what you'll be getting? X is your 1, Y is your 1, and this Z is your 1 divided by 1.5. 1 divided by 1.5. You can write it like this. You need to simplify it further, right? This is going to be 10 by 15. 10 by 15 means 2 by 3, right? 1.5 means it's going to be 10 divided by 15. So 2 divided by 3. Well, the ratio can never be in this format because over here you've got a fraction. So convert it into the simplest natural numbers. So multiply throughout by 3. When you multiply throughout by 3, this is going to be 3 is to 3 is to 2. So this is going to be the answer of this particular question. And I believe everyone already wrote this particular answer in the chats. Yes? Absolutely wonderful. Good job. Look at this question, guys. Look at this question. Look at this particular question. Quick. Someone is writing 332. Didn't we write the answer as 332? Yes, we wrote the answer as 332. Yes. Perfect. I'm given with a reaction. Reaction is A plus B gives product. Can you give it a try quickly? This is the reaction. Guys, I want you to use your brain first. Solve it. You're not supposed to write the question. Don't write it in your notebook. I'll send you the PDF afterwards. I want you guys to use the rough space. Solve the question. Let me know the answer, then I'll solve. Quick. You have to be very quick, right? And by looking at the chats, you'll get to know where you exactly are. What is the competition exactly? With who you are competing, right? By seeing the answers in the chats. Like people are continuously giving the answers, taking very, very lesser time to solve the questions. Right? So this is again one more way of saying it. Quickly. Majority is coming up with option D. Let's exactly see whether it's option D or not. First of all, this is the equation which you have. This is the reaction. Okay? As per the question, my dear students, if I write its rate law, R is equal to K, it's going to be concentration of A raised power X, concentration of B raised power Y. This is your rate law. I'm calling this as equation number 1. The question says a rate is doubled when the concentration of B is doubled. So when you are doubling the concentration of B, rate is getting doubled. Initially the rate was R, now it's 2R. When the rate is 2R, rate is 2R when the concentration of B is doubled. Now it's 2 times B. Right? Calling this equation number 2. The rate increased by a factor of 8 when the concentration of both the reactants are doubled. When you are doubling the concentration of both the reactants, rate becomes 8 times. So initially it was R, now it is 8R. When it is 8R? When concentration of both the reactants is doubled. Calling this is equation number 3. So how many equations do we have? My dear students, we have got 3 equations. Okay. Now you just need to divide, etc., etc. Okay. You'll get your X and Y. My dear students, if you think carefully, if I divide equation 2 by equation 1, R and R gets cancelled. So on left side we get 2. K and K gets cancelled. A raised power X, A raised power cancelled. B raised power Y, B raised power cancelled. So I'll be only left with 2 raised power Y on this side. So compare this. So from here, you are getting Y exactly equal to 1. So you got the Y value. Now what is left? X is left. What is left? X is left. What I'll be doing now, I'll be dividing equation 3rd by equation 2. If I divide equation 3rd by equation 2, R gets cancelled. 8 divided by 2 is 4 is equal to 2B cancels completely. K cancels. A raised power X, A raised power cancels. So already what you'll be having? You'll be having 2 raised power X here. Now when is it possible? This 4 you can write as 2 square. So 2 square is nothing but 2 raised power X. Comparing both, X is coming out to be what? X is coming out to be 2. So you got your X, you got your Y. So your rate law exactly will be of what nature? It will be R is equal to K, concentration of A raised power X, X was 2, and concentration of B raised power Y, Y is your 1. Perfect, this is the answer of the question. I believe all of you have solved this question properly. So it's option D, which is the correct answer of this particular question. Similar type of question I'm giving you. You need to give it a try. Similar type of question. Similar type of question, guys. What do you think? Similar type of question. Similar type of question I'm giving you. What do you think? Be very quick. Be very quick. For the reaction between A and B. So reaction is happening between A and B. Order with respect to A is 2 and order with respect to B is 3. The concentration of A and B are doubled. The rate will increase by a factor of what? Easy kill question you call this. Easy kill question you call this. As per the question, A and B are reacting and they'll be forming the product. Order with respect to A. Order with respect to A, which is represented by X, that's 2. Order with respect to B, which is represented by Y, that's 3. So you got your X and Y. Now write the rate law. R is equal to K. Concentration of A raised power X, matlab raised power 2. Concentration of B raised power Y, Y is your 3. Perfect. Now as per the question, what exactly are we doing? Concentration of both A and B are doubled. You are making this 2 times. You are making this 2 times. You are making this also 2 times. This will be 2 ka square, that will be 4. This will be 2 ka cube, 2 2s are 4 2s are 8. So 8 multiplied by 4 will be 32. So rate will increase by 32 times. Right? Rate will increase 32 times. Am I clear? Simple, basic question. Simple and basic question this is. Yeah? So this is getting 2 times, this is getting 2 times. So 2 ka square comes out to be 4. 2 ka cube comes out to be 8. 8 4s are 32. So rate will be increased by 32. Very easy and basic question this is. Very easy and basic question this is. Now, can you give this question a try? Well, I have not given any options here. You have to tell me the answer in the chats. Well, this is not one question. These are two questions actually. These are two questions actually. These are two questions. This is not just one question. Look at the question carefully and try to solve. Look at the question carefully and try to solve. My dear students, if you look at this particular equation, it's given in the balanced format. I told you in the yesterday's session, if you remember, for a homogeneous gaseous phase reaction carried out at constant temperature, rate can be either expressed in terms of moles per liter per second, or rate can be expressed in terms of pressure as well, right? So for the following reaction, the pressure of NO falls. So we are given the data for NO. I can write rate of reaction in terms of NO. I can write -1 divided by 2, right? Change in the concentration of NO divided by time interval. If I use this particular term to calculate the rate, I'll be getting the rate in moles, liter inverse, second inverse. Correct? My dear students, there is one more way of calculating rate. I'll be writing -1 divided by 2. Change in the what? Change in the pressure of NO divided by time interval delta T. If I use this particular expression, I'll be getting the answer in ATM second inverse. These are the two ways, right? You have to look at the options basically. You have to look at the options and accordingly you have to go ahead. Perfect. As per the question, the pressure of NO falls from this to this. All right, pressure of NO falls from this to this. So this was the initial pressure of NO. This is the final pressure and this is the time interval. So let's solve this particular equation first. R is equal to -1 by 2. Change in the pressure of NO, which will be final pressure of NO minus what? Minus initial pressure of NO divided by time interval is 10 seconds, right? I believe you can solve this one now. I believe you can solve this one now. And the answer is going to be in ATM second inverse. So this is one of the question, done and dusted. Look at the second question. Second question. If you use this particular term, you'll be getting the answer in moles per liter per second. So we have solved this particular question in ATM second inverse. Now, moles per liter per second. It's -1 by 2. -1 by 2. Change in the concentration of NO. Can I write, instead of concentration of NO, can I write pressure of NO divided by RT? I hope you remember. If your ideal gas equation, PV is equal to nRT. In the yesterday session, I've showed you, right? So P will be equal to N divided by VRT. What is N by V? N by V is concentration. So P is equal to concentration RT. So if I'm using the pressure of NO, so here has to be the concentration of NO and R and T. So concentration of NO is nothing. It is pressure of NO divided by RT. That's why I wrote concentration of NO is pressure of NO divided by RT. So R will be equal to -1 divided by 2. Change in the pressure of NO, which will be final pressure of NO. That is how much? 2.5 minus initial pressure of NO. That is 5 atm divided by time interval. You already know how much is that. That's 10 seconds. Time interval is 10 seconds. Now R and T, right? R and T. What is the value of R which we'll be using here? Quick. I have to get the answer in moles per liter per second, right? R has got three values. First value is 8.314 joules per Kelvin per mole. Second value is 0.0821 atm liter per Kelvin per mole. Third value of R, if you do not know, it is 1.98 calories per Kelvin per mole. Perfect. I have to get the answer in moles per liter. In which of the units do you see liter? Here I can see liter. So which value of R I'll be using? 0.0821, right? 0.0821. And let me tell you, in order to reduce the calculations, instead of 0.0821, you can use the term 1 by 12. 1 by 12 is also 0.0821. So R is nothing but 1 by 12. And temperature must be given in the question itself, 300. So multiplying it with 300 as well. Now it's a matter of calculation and you'll be getting the answer finally in moles, liter inverse, second inverse. If I'm clear, let me know once in the chats. Okay? If I'm clear, let me know once in the chats. This sort of a question can be asked. One, calculate the rate in terms of atm second inverse. Second, calculate the rate in terms of moles per liter per second. And this is the procedure which you need to follow to solve both the questions. Simple and basic this is. It is just you should be careful with the units basically. Nothing else. Yeah? Nothing else. Okay. Do you remember I have told you how do we approach to this particular question? I gave you a trick also. I gave you general approach of solving as well as trick also. So let's solve this question with the help of a trick. Let's solve this particular question with the help of trick. First of all, I want you guys to use your brain. What do you think? What should be the answer? What should be the answer of this question? Be very quick. You need to be very quick, guys. You need to be very quick. What should be the answer of this question? A lot of people are coming up with option A. Option D. Someone is saying video is not clear. You just change your settings. I think you are watching at 140p. Yeah? All right, people. First of all, the reaction that's given to us, 2A plus B gives C plus D. 2A plus B gives C plus D. If I write the rate law, R is equal to K, concentration of A raised power X, concentration of B raised power Y. This is your rate law. Perfect. Now, guys, think carefully. Think carefully. Think carefully. First of all, if you look at second and third experiment, in second and third experiment, one thing is common. You have kept the concentration of A as 0.3 molar. So, in your second and third experiment, you are not changing the concentration of A. So, imagine as if A is not here. What is happening to the concentration of B? From 0.2 to 0.4, you are making it 2 times. You are making it 2 times. So, you are making the concentration of B 2 times. Perfect. What is happening to the rate? Rate is becoming 4 times. Rate is becoming 4 times. 7 4s are 28, right? Rate is becoming 4 times. So when you double this is becoming 4 times. When is that possible? When is that possible? When you are doubling B, this is becoming 4 times, which is only possible if the power here will be 2. Then only 2 ka square will come out to be 4. So Y value I got to know as 2. Y value is 2, right? Erase whatever we have done. Erase whatever we have done. Now, my dear students, think carefully. Think carefully. Think carefully. We are done with half of the question. Second part. If you look at the first and the fourth experiment, the concentration of B is kept same. Concentration of B is kept same. Imagine B is not here. Concentration of B is kept same. Now, what is happening to the concentration of A? What is happening to the concentration of A? It is made 4 times, 0.1, 0.4. Concentration of A is becoming 4 times. If A is becoming 4 times, what is happening to the rate here? What is happening to the rate here? Check it out. 6 1, 6 4 is 24. So rate is also becoming 4 times. So when you are making this 4 times, rate is becoming 4 times. When is that possible? When the power here will be 1, then only 4 raised power 1 will be 4. If the power was 2, 4 ka square should have been 16 then. So here on making this 4 times, this is becoming 4 times. So you can categorically say the value of X is 1. So Y is equal to 2, X is equal to 1. So your rate law will eventually settle to what? Concentration of A raised power 1, concentration of B raised power 2. Do you see any of the option like this? A raised power 1, B raised power 2? Yes, it's option D, which is going to be the correct answer of this particular question. Am I loud and clear? Perfect. All right. Moving on to the next question. Moving on to the next question. Moving on to the next question. Okay. Look at this particular question, guys. We are given the reaction. I'll write the reaction till you solve this. 2 times N2O5, it gives 4 times NO2. With that, you're writing O2. Rate and rate constant. Rate of the reaction as well as the rate constant of the reaction. Both are given. Perfect. Wonderful. Rate of the reaction is 1.02 multiplied by 10 raised power minus 4. Write the units with it. Moles, liter inverse, second inverse. What is rate constant? Rate constant is 3.4 into 10 raised power minus 5 second inverse. The concentration of N2O5 at that time. When rate of reaction is this, rate constant is this. What will be the concentration of N2O5 at that time? What will be the concentration of N2O5 at that time? How you are going to approach this question? Try to understand. Just tell me one thing. How do you check the order of this particular reaction? Do you know what is the order of this reaction? How do you check order? I'm asking you, order. Don't tell me the answer. Tell me the order of the reaction. My dear students, if you remember, there is one way of checking the order of reaction with the help of units of rate constant. What are the units of rate constant here? Rate constant units are second inverse. Second inverse, if rate constant unit is second inverse, that means this reaction follows the first order kinetics. It is the first order reaction. It is the first order reaction. It is the first order reaction. Right? And by the way, this session is not only the question solving. I'll be giving you some extra topics as well. Okay? I'll be teaching you some extra topics as well. For example, you know, this time the level is going to be comparatively up. Okay? So there's a probability that questions might be asked from those part of the chapters which were not touched yet. For example, there are parallel reactions, right? Kinetics of parallel reactions, first order parallel reactions. I'll show you in the today's session what kinetics of parallel reactions is all about. From that also question can be asked, right? In the yesterday's session, I did not teach you the thermodynamics of the galvanic cell. Till now, question has never been asked, but the level will increase for sure. So maybe the question can be asked. Okay? I did not teach you the kinetics of first order gaseous phase reactions. Don't worry, that will be done today. But first we'll solve the questions. Some questions we'll solve, and eventually in between I'll teach you the things as well. I hope I'm clear with this. I hope I'm clear with this. All right. So my dear students, you understood this is the first order reaction. If it is the first order reaction, right, it's rate law. Rate law is generally written as R is equal to K, concentration of N2O5 raised per X, and X value over here is 1 because order is 1. Perfect. What am I supposed to calculate? Concentration of N2O5. So concentration of N2O5 is nothing. It is a rate divided by rate constant, right? Rate is given, rate constant is given. Take the rate is given 3.4 into 10 raised power minus 5 moles per liter per second divided by rate constant. What did I do? This is R divided by K. What is R? R is this. Okay. I just took reverse. R is equal to 1.02 into 10 raised power minus 4 divided by K is nothing but 3.4 into 10 raised power minus 5. When you solve this, the value comes out to be 3 molar, right? So 3 molar has to be the concentration of N2O5. I hope I'm clear. I hope I'm clear. Okay. So this sort of a question can be asked again. This, without even solving, you can solve this question. Without even solving, you can let me know the answer. What do you think? Be very quick. Be very quick. Be very quick, people. Be very quick. Be very quick. What do you think? When initial concentration of reactant is doubled, half-life of the zero order reaction. What about the half-life of the zero order reaction? Half-life of the zero order reaction, T half is equal to A naught divided by 2K. Where A naught is the initial concentration, you know it. When you double this, automatically this will double because both are directly proportional. So when you double the initial concentration of the reactant, your half-life of the zero order reaction, it gets doubled. There is no need to think a lot for this particular question. It's easy. It's easy. Okay, this question I want to see how you are going to solve. This question I want to see how you are going to solve. Because in this one, you have to use a bit of your brain. Bit of your brain. You have got the reaction A gives B, right? This is the reaction. Rate constant is given as 0.6 into 10 raised power minus 3. This is moles, liter inverse, second inverse. Okay. If the concentration of A is 5 molar, then concentration of B after 20 minutes will be. So initial concentration is given, right? The concentration of B after 20 minutes. The concentration of B after 20 minutes. Concentration of B after 20 minutes. Concentration of B after 20 minutes. How you are going to solve this? How you are going to solve this? Think over it. Think over it. Think over it, people. Think over it. First of all, if you look at the rate constant units, you can directly say it is a zero order reaction. It is a zero order reaction. Absolutely, it's a zero order reaction. From the rate constant units, I got to know that, right? Now, if you remember, how did we derive the expression for the zero order reaction, the integrate rate constant? How did we do that? If you remember, at time t is equal to 0, we assume initial concentration of reactant is A naught. So this has to be 0. What happens afterwards? When the reaction starts, concentration of reactant decrease with time. Concentration of reactant decrease with time. Let's say concentration of reactant left at time t is AT, right? And concentration of product formed at time t is BT. Perfect. We have to check at time t is equal to 20 minutes. At time t is equal to 20 minutes. What is the concentration of B? What is the concentration of B? Think carefully, guys. If you remember, we have our integrate rate equation as AT is equal to A naught minus KT. This is the equation, our integrate rate equation. Perfect. Now, the initial concentration of reactant is how much? A naught, right? The concentration of reactant left is 80. I had A naught. I am left with 80, right? So how much has got converted into product? I had A naught. I am left with 80. So how much has got converted into product? Can I say concentration of B at time t is equal to 20 minutes, which is BT. Initially I had A naught. I'm left with 80. So A naught minus 80, that is the amount which has got converted into product. So basically I have to get the value of A naught minus 80. Basically I have to get this value, A naught minus 80, right? Now guys, if I need to calculate A naught minus 80, so in this particular equation, I'll write this equation as A naught, would take 80 on this side, A naught minus 80, take KT on the other side is equal to KT. This particular term, A naught minus 80, what do you call as? Concentration of B at time t, right, is equal to K multiplied by T. What do we have to calculate? Concentration of B at time t is equal to 20 minutes. It has to be equal to what? K times T. What is K? 0.6 into 10 raised power minus 3, right? Moles per liter per second. Time is 20 minutes, so convert it into seconds multiplied with 60, right? So this is going to be the answer. Just solve this and get the exact value, right? Are you clear? Are you clear with this? Say yes or no in the chats. Are you clear? Yeah? Perfect, guys. So after solving, the answer will come out to be 0.72 molar. I hope you got to know how do we approach these sort of questions, right? I hope you got to know how do we approach these sort of questions. This is one more question wherein I want you guys to use your brain a bit. Anyways, I'm going to give you one trick as well. I'm going to give you one trick as well for solving this question. Look at the question carefully first of all. Half-life of the zero order reaction is given. When the initial concentration of reactant was 2 molar, how much time does it take for the concentration to reduce from 0.5 molar to 0.25 molar? How you are going to solve this? Subhash, in the last question, they had given the concentration 5 molar or something, right? That is just to distract you so that you use some other approach. Akib, there is no need to consult NCERT. I told you, follow yesterday's session and today's session. That's more than sufficient. Okay, that's more than sufficient. Enough. Enough. Let me show you a general way of solving this sort of a question, right? Let me show you the approach first of all. Let me show you one quick approach. After that, you can solve the question. For example, you have got the reaction A gives B. I'm assuming this reaction follows the zero order kinetics. It's a zero order reaction. Okay. Imagine. At time t is equal to 0, the concentration of this reactant is A naught. This is 0, for example, right? Let's say at time t is equal to T1. At time T1, let's say the concentration of reactant which is left, that is AT1. Let's say at time t is equal to T2, concentration of reactant is AT2. Concentration of reactant left is AT2. Now guys, understand. At time T1, the concentration of reactant left is AT1. At time T2, the concentration of reactant left is AT2. Okay. If you look at the first time interval from here to here, this time interval is 0 to T1, right? So this time interval is basically your T1 time interval. So in your T1 time interval, can I say the concentration of reactant is changing from A0 to AT1? Yes. In your T1 time interval, the concentration of reactant is changing from A0 to AT1. Now, if I select one more time interval here, if I select one more time interval, let's say this is the time interval which I'm selecting from here till here, right? This is the T2 time interval, right? In your 0 to T2, in your T2 time interval, the concentration of reactant is changing from A0 to AT2. In your T1 time interval, the concentration of reactant is changing from A0 to AT1. In your T2 time interval, the concentration of reactant is changing from A0 to AT2, right? But what do we have to calculate? If I ask you, what about this time interval? From here to here. From here to here. What about this time interval? What you will be doing? You will say it will be T2 minus T1. This time interval has to be nothing but T2 minus T1. In this particular time interval, the concentration of reactant is changing from AT1 to AT2. Right? In this particular interval of time, the concentration of reactant is changing from AT1 to AT2. Agreed? Okay? In this particular time interval, the concentration of reactant is changing from AT1 to AT2. Now, people, understand. Whenever you have a question, in which you have to check this particular time interval, what kind of equation you use for zero order kinetics? What you'll be doing exactly? You'll be using one equation like this. You know the equation, general equation AT is equal to A0 minus KT. This is your general equation for zero order. But I don't want you guys to use this equation. One direct result. Write this equation in one more format. Instead of AT, write AT2. Instead of A0, write AT1. Minus K, instead of T, write T2 minus T1. Write T2 minus T1. This is the equation which I want you guys to use when you have the question of this particular format. Okay. Now guys, I believe you are done. T half is 1 hour. If T half is 1 hour, what does that mean? That means A0 divided by 2K is equal to 1 hour. What is A0? Initial concentration. Initial concentration is 2 molar. So it is 2 divided by 2, 1. So 1 divided by K is 1. Or I can say K is equal to 1 mole liter inverse second inverse. So you got the rate constant first of all. If you got the rate constant, what is AT1, AT2? AT1 is the concentration. AT1 is the concentration at time T1. AT2 is the concentration at time T2. What do I have to calculate? I have to calculate this particular time interval, right? Now guys, it's mentioned that concentration of reactant initially was 2 molar. So this was 2 molar as per the question. Then it reached 0.5 molar and at the end it reached 0.25 molar, right? So AT2 is nothing, it is 0.25. AT1 is nothing but 0.5 minus K is 1 and time interval T2 minus T1 I can represent with delta T. So your delta T comes out to be nothing, it will be 0.25 hours. Am I clear with this? Am I clear with this, people? Quickly. When you get this sort of a question, this is the approach which you will be using. Okay? Perfect. And it is particularly valid for zero order reactions. Whenever you are supposed to check how long will it take for the concentration of reactant to change from AT1 to AT2, that means this time interval you are supposed to calculate. And this is the equation which you'll be using at that point of time directly without giving a second thought. Now, if the similar sort of question is asked in the first order kinetics, what do we do there? If the similar sort of question is asked from the first order kinetics, what do we do there? Let me show you that. If the similar sort of question, take a note of this one. And edit in your yesterday's notes. Okay? For example, you have got a first order reaction like this. A gives B. Guys, I'll have to turn the lights off, right? Okay, let's say this is your first order reaction. Imagine this is your first order reaction, okay? Let's say at time t is equal to 0, your initial concentration of reactant is A0. At time t is equal to T1, your concentration of reactant is AT1. At time t is equal to T2, your concentration of reactant is AT2. Okay? At the same time, I'm assuming at time t is equal to T1, let's assume rate of reaction is R1. At time t is equal to T2, let's say rate of reaction is R2. Whenever you see this kind of the question, this kind of the approach. Whenever you see this sort of a situation given in the first order, whenever you see this sort of a situation given in the first order, initial concentration given, then two different times, two different concentrations or two different rates, right? Now, what do we do at that time? What kind of equation do we use? You know your integrated rate equation, that is K is equal to 2.303 divided by T. It's going to be log of A naught divided by AT. This is your general first order equation. But I don't want you guys to use this equation here in this particular situation. What I would want you guys to do is, I would want you guys to write K as such, 2.303 as such. Instead of T, you write T2 minus T1. T2 minus T1 log of. Instead of A naught, I want you to write AT1. Instead of AT, I want you guys to write AT2. This is the situation, this is the expression which I want you guys to use in that sort of equation. If imagine in the first order reaction, you are supposed to calculate the time interval in which the concentration of reactant is changing from AT1 to AT2. Calculate the time interval in which the concentration of reactant is changing from AT1 to AT2. That means this time interval from here to here you are supposed to calculate. That means T2 minus T1 time interval you are supposed to calculate. I want you guys to use this equation, number one. Or if you do not want to use this equation, then use this equation. K is equal to 2.303 divided by T2 minus T1 log of. Instead of AT1 by AT2, just use R1 divided by R2. Rate of reaction at time T1, rate of reaction at time T2. These are the two expressions which will solve all your problems. And it is basically valid for what? First order reactions. I want you guys to take a note of this particular situation in your yesterday's notes. Okay? Am I clear? Am I clear, people? Am I clear? Say it in the chats. Am I clear? Say it in the chats quick. Look at the question which is asked in your NEET 2020. I want you guys to kill this question. Half-life of the zero order reaction is given. Initial concentration of the reactant is given. Rate constant we are supposed to calculate. Kill it. Quick. NEET 2020. I want you guys to solve this quickly. Quickly, guys. Imagine the zero order reaction which is given to us, that's A gives B. This is our zero order reaction, right? This is our zero order reaction. Initial concentration of reactant is given as how much? 0.02 molar, right? Half-life of the reaction is given as 100 seconds. Half-life is given as 100 seconds. Now, since this reaction follows the zero order kinetics, now what do? You know, in the zero order kinetics, T half is equal to A naught divided by 2K. Perfect. T half is equal to A naught divided by 2K. Can I say K is nothing but A naught divided by, 2 times the T half. What is A naught? A naught is 0.02 divided by 2 multiplied by, what is T half? T half is 100. Perfect. I believe it's clear. So this will be 2 into 10 raised power minus 2 divided by 2 into 10 raised power 2. So 2 to cancel. This comes up. So 10 raised power minus 4. And it's going to be, since it's a zero order reaction, moles later inverse, second inverse. Is there any option as 10 raised power minus 4? Yes, I can see this option as 10 raised power minus 4. Done? Simple. Right? This sort of equation you should be able to solve if it is asked. Right? By the way, this question which we solved few minutes back, this was again your NEET 2018 question. Do you remember the approach, how we solved this? Or no, it is a different one. Is it the same or different? Is it same or different? Calculate the concentration of B after 20 minutes. It is a similar question. Right? It is a similar question. It is a same to same question, I think. Yeah? Did we solve this? I'm just asking you, did we solve this already? We have solved this already. So this was the approach of solving. Okay, this was your 2018 NEET question. All right. Now here is a misprint 2022. But I think I remember the graph which was given. I think so. Not sure. I'm not sure, but I think I remember this question. This was 2022. They had given the graph like this. Okay, yes. This was your y-axis. This is your x-axis. And the graph was given like this. Yes, the graph was given like this. This was the question. This was the question. Can you now check it out? First of all, in every option, there is zero order and first order, zero order and first order. Zero order, first order. Guys, you should be able to solve this question here. There should be no second thought in solving this question. There should be no second thought in solving this question. No second thought in solving this question. See, for a zero order reaction, if you want to plot a graph between rate versus time, rate versus concentration of reactant, see, in the zero order reaction, rate of the reaction is independent of the concentration of reactant. The graph will be like this, right? Graph will be like this. For the first order reaction, if you plot the graph between T half and concentration of reactant. For the first order reaction, you know T half is nothing but 0.693 divided by K. So T half is independent of concentration of reactant. So it's the same. Perfect. Now find the options. If you look at option C, for the zero order reaction, when you plot a rate along y-axis, concentration along x-axis, the graph will be this. Now, for the first order reaction, when you plot T half along y-axis, concentration along x-axis, the graph is again the same. So the correct answer of this particular question has to be option C. Is that clear? All these graphs we have discussed in detail in the yesterday's session. I hope that you guys remember that. NEET 2022, one more question was asked from the kinetics. Can you check it? The reaction is first order. The reaction is first order. A gives P. This is the reaction. A gives P. Okay. Initial concentration of reactant, which is A naught. This value is given to me as 0.1 mole. Right? After 5 minutes, the concentration of reactant left, which I'm representing with AT, that is 0.001 molar. What do we have to calculate? Rate constant of the reaction. But this time we have to calculate it in minute inverse, not second inverse. Can we check it? People? I'll be simply using what? I'll be using the integrated rate equation for the first order kinetics. You know, your K is nothing but 2.303 divided by T, and it's log of A naught divided by AT. Do you remember I gave you one expression like this? So K has to be equal to 2.303 divided by T. What is T? 5 minutes. Right? I'm using this condition in the question. T is equal to 5 minutes. Log of A naught was 0.1. So 10 raised power minus 1 divided by AT is your 10 raised power minus 3. Perfect. Now the question is almost done and dusted. So K is nothing but 2.303 divided by 5. This will be log of 10 raised power 2. Right? It comes up. It becomes 10 raised power 2. So log of m raised power n is n log m. So 2 comes to the front. Right? 2 comes to the front. This becomes 4.606 divided by 5. And now the units are going to be minute inverse because you used the value of time here in minutes, right? Now it is just a matter of calculation. It will be 5 9s are 45. So this will be 0.9 something. 0.9 minute inverse is going to be the answer of the question. Yes? Done? I hope I'm clear. I hope I'm clear, people. I hope I'm clear with this. This is one more amazing question. Let me tell you, this question was not asked in NEET. This question was not asked in JEE mains, but this question was asked in advance. This question was asked in advance. But I believe, if you have watched the yesterday's session, you should be in a position to solve this question. This was the integer type question which was asked, I think like 5-7 years back. But you can solve this question. That is the reason why I have particularly picked this question. Because that confidence should be there, right? Whatever type of the question can be asked from, is asked from the kinetics, you should be able to solve that. See guys, what the question is all about. An organic compound undergoes a first order decomposition, right? So the reaction is first order. The reaction is first order. A gives B, right? Assume that the initial concentration of reactant is A0. This is 0. Understand carefully what I'm saying. It's easy. Understand carefully. Time taken for its decomposition to 1/8 and 1/10 of its initial concentrations are T1/8 and T1/10. So as per the question, at time T is equal to T1/8, how much reactant is left? 1/8 of A0 is left. So that will be A0/8. This is the concentration of reactant left at time. This is the concentration of reactant left at time T is equal to T1/8. Similarly, as per the question, at time T is equal to T1/10, how much reactant is left? It is A0/10, 1/10 of initial. So tell me how many conditions did we get? I got 2 conditions. This is condition number 1 and this is condition number 2. This is condition number 2, right? Now people, the reaction is following which kinetics? First order kinetics. In the first order kinetics, our integrated rate equation, one of the format is T is equal to 2.303 divided by K log of A0 divided by AT. Log of A0 divided by AT. This is our general expression. This is our general expression. Now, my dear students, if I fit this condition here, instead of T, I'll write T1/8. T1/8 is equal to 2.303 divided by K log of A0 as such divided by, what is AT? AT in the condition is A0/8. A0/8. So A0 cancel, 8 comes up. 8 comes up. Or else 8 can be written as 2 raised power 3. It can be written as 2 raised power 3. Log of m raised power n is n log m. It can be written as 3 log 2. It can be written as 3 log 2, right? 3 log 2. 3 log 2. Log 2 is how much? 0.3. So instead of entire thing, 3 into 0.3 is nothing but 0.9. So this is the value I got till now. Let me call this as equation number 1. Now, if I put the same condition, second condition in this expression, instead of T, I'll be writing T1/10 is equal to 2.303 divided by K log of A0 divided by, what is AT here? AT here is A0/10. So A0 cancel, 10 comes up, log of 10 is 1. Log of 10 is 1. So this is your equation number 2. This is your equation number 2. As per the question, I'm supposed to get this value. I'm supposed to get the value of T1/8 divided by T1/10 multiplied by 10. This value I'm supposed to get. T1/8 is how much? 2.303 divided by K multiplied by 0.9 whole divided by. T1/10 is how much? 2.303 divided by K, and I'm supposed to multiply it with 10. So this term cancel. 0.9 multiplied by 10 comes out to be 9. So 9 is going to be the answer of this question. Simple integer based question. Am I clear? Am I clear, people? Am I loud and clear? Is it clear, people? Just a second, people. Just a second, just a second. Okay, I'm moving on to one more question now. I hope this sort of a question, if it is asked, you should be able to solve this. Now look at this. Look at this question. Someone is saying, I think I should go for IIT now. Yes, why not? As per the question, log AT versus T curve is given. This angle is given 135. We have to choose the half-life. We need to choose the half-life of the reaction. Quick, people. Quick. It's a simple question. I think this sort of a question we did in the yesterday's session as well. Well, if you look at this particular curve, log AT versus T, this curve, this sort of a curve used to come for the first order reactions. This was for the first order reaction because you know your log of AT is equal to log of A naught minus K divided by 2.303 multiplied by T. This was the equation, one of the format which I gave you, right? Since in this question, log AT you are plotting along y-axis, T you are plotting along x-axis. So this becomes your M, sign is minus, and this is C. Y is equal to minus mx plus C. So it has to be a straight line with negative slope, right? What about the slope of this particular curve? Slope of this particular curve is nothing but minus K divided by 2.303. What is slope? Slope is tan of theta. Theta is the angle which the curve makes with the positive x-axis in the anti-clockwise direction. So it is tan of is equal to tan of 135. Tan of 135 is nothing but minus 1. So over here I can get the value of K, 2.303. And since in the options the units are minutes, so I'm using minute inverse here, rate constant. I got the rate constant. Right? Since I got the rate constant, what am I supposed to calculate? I'm supposed to calculate half-life. How do we get the half-life? Half-life is equal to 0.693 divided by K, right? So it's going to be 0.693. K is nothing but 2.303 minute inverse. This value, when you solve this, I think you'll get this value as 0. How much? 0.3 minutes. Am I clear with this? Right? So option A has to be the correct answer of this particular question. It has to be the correct answer of this particular question. I hope you are in a position to solve this sort of a question as well. Now guys, the approach which I gave you a few minutes back, that scenario which I told you for the first order, do you remember that scenario? K is equal to 2.303 divided by T2 minus T1 log of AT1 by AT2 or log of R1 by R2. Here is the question. And let me tell you, this question is again not asked in NEET. This question is again not asked in mains. Again, this question was asked when there used to be IIT examination. There was no JEE mains, JEE advanced at that time. It used to be IIT at that time. I think this question was asked in 2010 or 2009, something like that. But why I came up with this question? Because I know you can solve it now. Because I have given you the direct result by means of which you can check it out. Can you give it a try? In between, if we solve these sort of questions, it will boost up your confidence. That's my main motto. Okay? Wow, somebody solved it already. Wow. Are you sure? How exactly did you solve this? Amazing. See guys, imagine that the reaction is A gives B. And as per the question, it's following the first order kinetics, right? As per the question, let's say the initial concentration of reactant is A naught. Okay. Now, as per the question at time T1, which is equal to 10 minutes, at time T1, which is equal to 10 minutes, rate of the reaction is given to me as 0.03 moles liter inverse second inverse. At time T2, at time t2, which is equal to how much? 20 minutes. At time t2, which is equal to 20 minutes. Rate of the reaction R2 is nothing but how much? Okay, this was 0.04. Now this is 0.03 moles, liter inverse, second inverse. What am I supposed to calculate? I'm supposed to calculate half-life of the reaction. I'm supposed to calculate half-life of the reaction. T half is to be calculated. How do you calculate T half? How do you calculate T half in the first order kinetics? 0.693 divided by K, right? So in order to calculate the half-life, what do I need? I need K. How do I get the K? I gave you the one expression few minutes back. 2.303 divided by, this is T2 minus T1. This is log of R1 divided by R2. So K has to be equal to 2.303 T2 minus T1. T2 minus T1, 20 minus 10 is 10. Log of R1 divided by R2. R1 is 0.04, R2 is 0.03, right? This becomes 4 by 3. Log of 4 by 3 will be, log of 4 by 3 will be, log of 4 by 3 will be log of 4 minus log of 3. Log of 4 by 3. So K will be nothing but 2.303 divided by 10. Log of 4. How much log of 4 will be? 0.6. Log of 3 is how much? 0.47. Perfect. Yeah, you can solve it here and get the rate constant, which is going to be in minute inverse, because here delta T you are taking in minutes. If you got the K, put the value of K here. When you put the value of K here, as far as I remember the answer, it will be 24 minutes. So half-life of this reaction is nothing but 24 minutes. Am I clear? Am I clear with this? Am I clear with this? I'm asking everybody. I'm asking everybody. Am I clear with all these things? Yes, you should be able to solve this sort of equation as well. Okay. All right. Do you remember this sort of equation we also solved in the yesterday session? Do not look at your notes. Solve it right now again. Without seeing the solution, you should be solving this question. Without seeing the solution. Without seeing the solution, I'm saying. You have to solve this question. Without seeing the solution, try to solve this question. See guys, the reaction that's given to us, that is C4H8, which is your cyclobutane. It is getting converted to ethylene, C2H4. This is the reaction. First thing, if I ask you what is the order of the reaction, look at the rate constant units. Second inverse. That means it's a first order reaction. The reaction follows the first order kinetics. Number one. As per the question, in what period of time will the molar ratio of these two be 1? What does that mean? Imagine at time t is equal to 0, we have got A moles of this reactant, and this is 0. Imagine at time t, out of A moles of reactant, X got dissociated. So I'll be left with A minus X. Now 1 mole gives 2, so X are going to give us 2X. These are the moles of reactant left at time t. These are the moles of product formed at time t. I think, let's assume this is the time. Let's assume this is the time at which the moles of reactants and products got equal. Let's say this is the time at t. I would say, let's assume A minus X is equal to 2X. Because if A minus X is equal to 2X, then only I can say A minus X divided by 2X is equal to 1. What does that mean? That means the moles of reactant divided by moles of product is equal to 1. That's something I was supposed to calculate. That's what I'm supposed to calculate. At what time will the ratio of moles of products to reactants, right? At what time will the ratio of their moles come out to be 1? When the ratio of moles of reactant product comes out to be 1, what does that mean? That means their moles are equal, right? That means their moles are equal. As simple as that. As simple as that. I hope I'm clear with this. I'm assuming this is the time at which the moles of reactants products are becoming equal. So this is the time at which the ratio of their moles will be 1, right? So A minus X, from here I can say X is nothing but A divided by 3. So I got the value of X. What do I have to calculate? I have to calculate this time. I have to calculate this particular time. I have to calculate this particular time. At what time the moles of reactant products became equal? At what time the ratio of the moles became 1? Since it's the first order reaction, I'll be using the first order kinetics. You know, your T is equal to 2.303 divided by K. It is a log of A naught divided by AT. Perfect. This is something which you know. This T we are supposed to calculate. T is equal to 2.303 divided by K value is given to me as 2.3 into 10 raised power minus 4. Log of, what is A naught? Initial moles or initial concentration, whatever. So A divided by AT. This AT concentration of reactant left, moles of reactant left. So it is A minus X. It is A minus X. X is A by 3. So A minus A by 3 comes out to be 2A by 3. So in the denominator, you have got what? You have got 2A divided by 3. A got cancelled. So it is 3 by 2. So it is a log of 3 by 2. Log of 3 divided by 2 means it is the log of 3 minus log of 2. Perfect. So this term cancel. T will be 10 raised power minus 4 goes up. It's 10 raised power 4. Log of 3 is 0.47. Log of 2 is 0.3. This will be 0.17 into 10 raised power 4. The value will be 1700 and the answer is going to be in seconds. Is it clear? Is it clear, people? So what is meant by this particular thing? It means that at 1700 seconds, the moles of reactants and products have got equal. At 1700 seconds, the ratio of moles of reactants and products have become 1. I hope I am clear to everyone. Chalo, NEET 2020. NEET 2020. What do you think about this? What do you think about this? Quickly, people. The rate constant of the first order reaction is this. The time required to reduce 2 grams of reactant to 0.2 grams. Again, a simple question. You have got the reaction as A gives B, right? Okay. Let's say the initial amount of reactant, which I'm representing with A naught, that is 2 grams. Perfect. Let's say at time T, the amount of reactant left, which I represent with AT, that is 0.2 grams. I have to calculate in what period of time will the amount of reactant go from 2 grams to 0.2. So I have to calculate this time interval. Look at this particular condition carefully. At time T, AT is equal to 0.2, right? Now, since the reaction follows the first order kinetics, so I'll be using the first order integrated rate equation. You know, T is nothing but 2.303 divided by K. It is a log of A naught divided by AT. Equation is done already, right? So T is equal to 2.303 divided by K. K is nothing but 4.6 into 10 raised power minus 3, right? This is log of, what is A naught? A naught is 2. What is AT? AT is 2 into 10 raised power minus 1, 0.2. So 10 comes up, log of 10 is 1. This term is 1. So this will be 1, this will be 2. So T will be 1 by 2 is 0.5. 0.5 into 10 raised power 3 comes up. So T will be equal to 500 seconds. Is there any option like that? Yes, option B. Done? Yes? Am I clear, people? Am I clear? Am I clear? Quick, everyone. This is your NEET 2019 question. You should be able to solve this one as well. It is again of the similar type. People. Let me turn the lights on. It is again of the similar type. Right? And it's a very short and precise question. The question is, if the rate constant of the first order reaction, I'm given the first order reaction, A gives B, right? As per the question, it's a first order reaction. Its rate constant is K. Okay. Time required for the completion of 99% of the reaction. Right? Time required for the completion of 99% of the reaction. So we have to calculate how much time does it take to complete 99% of the reaction. Do you remember in the yesterday's session, I gave you one expression. Time taken to complete X% of the reaction. X% of the first order reaction is equal to 2.303 divided by K log of 100 divided by 100 minus X. This is one expression which I gave you yesterday. Okay. How much percentage of the reaction has to get completed? 99%. Right? So put the value of X as 99. So T 99% will be equal to 2.303 divided by K. It will be log of, this will be 100 divided by 100 minus 99 is 1. Right? So 100 can be written as 10 raised power 2. 100 can be written as 10 raised power 2. Log of m raised power n log m. So it's going to be 2 log 10. It's going to be 2 log 10. So this is 2. Log 10 is 1. So the value will be 4.606 divided by K. So this is the time taken to complete 99% of the reaction. Is there any option like that? 4.606 divided by K. So it has to be option C, which has to be the correct answer of this particular question. Am I clear? Am I clear, people? Am I clear? 2017. A first order reaction has a specific reaction rate. That means rate constant. Has 10 raised power minus 2 second inverse. How much time will it take for 20 grams of reactant to reduce to 5 grams? Similar sort of question which we did like 2-3 minutes before. Right? 2-3 minutes before. What is your initial amount of reactant? 5 grams. Right? So at time t, how much reactant is left? 5 grams. Sorry, how much? Just a second. Initial amount of the reactant is given to me as 20 grams. And at time t, the amount of reactant left is 5 grams. Okay, right? And imagine this was your reaction. Reactant giving product. Perfect. So this was your time t is equal to 0. This is time t, right? And at time t is equal to 0, this was 0. This is the scenario basically. I believe you can solve this. So a lot of people are already saying it has to be option C. Are you sure? Are you sure? Again, the integrated rate equation, people. Again, the integrated rate equation. You can say T is equal to 2.303 divided by K. It is the log of A naught divided by AT, right? So T will be equal to 2.303. What is K? K is 10 raised power minus 2. Log of A naught. A naught is 20. AT is 5. 5 and 5, 4. So this has to be log of 4. This has to be log of 4 here. Perfect. Log of 4. Log of 4 is 2 ka square, right? So log of 2 raised power 2, which is 2 log 2, which is 2 log 2. So 2 comes to the front. Log 2 is nothing but 0.3. Log 2 is nothing but 0.3. Correct? Just the matter of calculation now. Just the matter of calculation now. This becomes 4.606 multiplied by 0.3 multiplied by 10 raised power 2. Perfect. So T will be equaled. It will be 460.6 multiplied by 0.3. So T will be equal to 3, 6, 18, 3, 4, 12, 13. So it is going to be 138 seconds. Is there any option like that? Option C is the one which is the correct answer. Am I clear? Just the matter of calculation, nothing else. If you remember the expression, you are done. If you remember the expression, you are done. Okay? Perfect. This similar question was asked in 2 sessions. The similar question was asked in 2 sessions. What do you think about this one? Give it a try. Give it a try. A first order reaction which is 30% completed has a half-life, 30% complete in 30 minutes, has a half-life of. As per the question, 30% of the reaction is getting completed in 30 minutes. This is something which is given to me. The reaction is first order. A gives B. Let me use a general approach, which you guys have been solving, which you guys have been using. And after this question, I'll teach you first of all some other things, then we'll move on to the other questions. Right? See guys, 30% reaction is completed in 30 minutes. Time taken to complete X% of the reaction is equal to 2.303 divided by K. It is a log of 100 divided by 100 minus X. Okay? Someone is asking, Sir, aap kya padha rahe ho? I am teaching English. English grammar is right now going on. English grammar. Right? Right? This is your noun. Correct? Perfect. One is pronoun and other one is, what do we call them? Conjunctions, right? Something was there, right? Okay, so noun is the name of a place or a thing, right? Noun is the name of how do we define it? Something, name, place, thing was there, right? Oh, verb used to be there too. Yeah? A lot of people are coming, huh? Anyways, as per the question, 30% of the reaction is complete. So X is 30. So take the value of X as 30. So time taken to complete 30% of the reaction. So T 30% is given to me as 30 is equal to 2.303 divided by K. This is log of 100 divided by 100 minus 30 is 70. Perfect. 100 minus 30 is 70. So from this particular equation, can't we get the value of K? Because everything is given. We can get the value of K. Once we get the value of K, after that, calculate the half-life. How do we calculate the half-life? T half for the first order is nothing but 0.693 divided by K. K you would have calculated here, put it here, and get the half-life. Isn't it simple? Isn't it simple, people? Am I clear with this? Am I clear with this? Now, guys, before doing other questions, I need to teach you something. Or let's do one more question, then I'll teach you a concept, an important concept, which may be asked. Can you give it a try? I'll give you the break exactly at 1:15. Find out the time required for 2/3 completion of the first order reaction. Rate constant is given. Simple. Again, simple. You are given the first order reaction A gives B. This is your first order reaction. At time T is equal to 0. Initial concentration is A0. This is 0. Right? Perfect. At time is equal to T 2/3. At time T is equal to T 2/3. Find out the time required for 2/3 of completion. 2/3 completion. What is meant by 2/3 completion? Initially, I took A0. Out of A0, 2/3 got converted into products. So I'll be left with A0 minus 2/3 of A0, which will be A0 divided by 3. So this is the amount of reactant left at time T is equal to T23, 2 by 3. Right? Perfect. I'll be using this condition in the in the integrated equation. You can say T is equal, for the first order kinetics, T is equal to 2.303 divided by K log of A0 by AT. This is something which we already know. Perfect. So T we have to calculate, which I call as T 2/3 is equal to 2.303. What is the value of K? K value is given to us as per the equation, which is 4.3 into 10 raised power minus 4 log of A0 divided by, what is AT? AT is A0 by 3. So A0 and cancel, 3 comes up. Log of 3 is 0.47, right? So instead of this whole term, I'll be writing 0.47. Now solve this. and get the value of T half. That's all, right? And the answer is going to be in seconds. Am I clear? Am I clear, people? Am I clear? It's a simple one, right? Time taken to complete 2/3 of the reaction. 2/3 completion means 2/3 of reactant is getting converted into product. If 2/3 reactant is getting converted, how much I'll be left with? A naught minus 2/3 of A naught. That will be 80. That will be the concentration of reactant left. I hope this sort of equation you can solve from now on easily. Okay. Now, guys. Now. Okay, one more amazing question is there, and I feel you won't be able to do it. Why do I think so? I feel I've already demotivated you, right? Or you will be able to solve, but there might be one mistake which you will do. There might be a mistake which you will do. There might be a mistake which you can do here. Look at the question carefully. I feel you might do a mistake in this question. See, guys. See, look at this question. It's a nice one. It's a good one. It's a good one. It's a good one, people. It's a good one. Yeah? As per the question is concerned, if you look at the reaction is given in the format A gas, it gives B gas plus 2 times C gas. This is the reaction that's given to me, right? As per the reaction, as per the question, the reaction is taking place in a container. The reaction is taking place in a container, and volume of that particular container, volume of the vessel is nothing but 2 liters. Okay? Whatever is going to happen, everything is going to happen at constant pressure temperature. So pressure temperature has been kept constant. Pressure temperature has been kept constant. Initially, as per the question, we are starting with 0.1 mole reactant. So this will be 0, this will be 0, because the reaction has not started yet. The reaction has not started yet. Now, my dear students, what do we have to calculate? Find the concentration of A after 250 seconds. Find the concentration of A after 250 seconds. Concentration of A at 250 seconds. What is concentration? It will be moles of A divided by volume of the system in liters at 250 seconds. Right? Right? Concentration of A at 250 seconds. Moles of A at 250 seconds divided by volume of the system in liters at 250 seconds. Try to understand. At time t is equal to 250 seconds. We have to calculate the concentration of A at 250 seconds. Now, what is this 250 seconds? But dear students, if you look at the rate constant unit, it is second inverse. That means the reaction is first order. If it is first order, can't we calculate its half-life? We can do that. If you calculate the half-life of the reaction, it will be 0.693 divided by K. What is K value? K will be 2.77 something into 10 raised power minus 3. When you solve this term, you will get the value exactly as 250 seconds. Do you get it? When you solve this particular term, you'll get the value exactly as 250 seconds. What are we supposed to calculate? Calculate the concentration of A left at 250 seconds. What is 250 seconds? Half-life. So basically, we have to calculate the concentration of A left when 50% reaction is complete. When 50% reaction gets completed, we have to calculate the concentration of A at that time. Yeah? Right? So we got to know this 250 seconds is your half-life. Perfect. At the half-life, what happens? 50% reaction gets completed. 50% reaction gets completed. So initially, I took 0.1 moles of reactant. At half-life, how much reactant I'll be left with? If 50% got converted into products, that means 50% will be left. So 0.1 divided by 2 will be left. These are the moles of reactant left at 250 seconds at half-life. Now, it's not done yet. It's not done yet. 1 mole gives 1 mole. So how much got converted? I took 0.1. I took 0.1 in the beginning. Out of 0.1, out of 0.1, 0.1 by 2 got converted. 1 gives 1, 0.1 by 2 gives 0.1 by 2. 1 mole gives 2 moles. 0.1 by 2 gives 2 into 0.1 by 2. 2 into 0.1 by 2. That comes out to be 0.1. My dear students, if you look carefully, these are the moles of all the reactants and products which are present in the container at 250 seconds, at half-life, right? Now, if you are thinking that we are supposed to calculate concentration of A at 250 seconds, at half-life, if you are thinking, you will do something like this: Na divided by volume of the vessel in liters, number of moles of reactant at 250 seconds is 0.1 divided by 2. Volume of the vessel is 2 liters. The answer will be 0.1 divided by 4 molar. You are absolutely wrong. And that will be one of the options here. That will be one of the options here. You're absolutely wrong if you are following this procedure. Why is that? Why is that? Why is that? See, I'll tell you why is that. I'll tell you why is that. First thing, I got to know already how many moles of reactant are there in the container at 250 seconds. 0.1 by 2. But, see, this is in gaseous phase, gaseous phase, gaseous phase. Do you know PV is equal to nRT? PV is equal to nRT. PV is equal to nRT. As per the question, your pressure and temperature is constant. Your pressure and temperature is constant. R is already constant. So I can say volume is directly proportional to moles. Volume of this is directly proportional to moles. That means if moles change, volume changes, right? If moles increase, volume will increase. If moles decrease, volume will decrease. There will be one equation which I can use over here. V1 by V2 is equal to N1 by N2. This can be used. Volume is directly proportional to moles. So V1 by V2 is equal to N1 by N2. Now guys, initially, before the start of the reaction, how many initial moles I had? How many initial total moles I had? I had only 0.1 moles. At that point of time, what was the volume of the vessel? 2 liters. What is the volume of the vessel? 2 liters. Now, at 250 seconds, how many total moles I have? This plus this plus this. Total moles now are 0.2. Have the moles changed? Yes, total moles have changed, increased. That means volume of the system would also have increased. Let's say now the volume is V2, right? Let's say now the final volume is V2. So V1 by V2 is equal to N1 by N2. V1 is 2. V2 I'll be calculating from here. N1 is 0.1. N2 is 0.2, right? So V2 comes out to be equal to 4 liters. Now, at 250 seconds, at the half-life, the final volume of the system is not 2 liters. The final volume of the system is 4 liters. Here you have to divide with the final volume. You got it? Concentration of A at 250 seconds will be moles of A at 250 seconds divided by volume of the system at 250 seconds. Volume of the system finally at 250 seconds is how much? 4 liters. The answer is 0.1 divided by 8 molar. This is the actual answer of the question. Quickly let me know in the chats if you got to know how do we solve this particular question. Am I loud and clear? Am I loud and clear? Am I loud and clear? Initially, their total moles were 0.1. At 250 seconds, total moles are this plus this plus this in the container, right? So moles are increasing. Total moles are increasing basically. If total moles are increasing, volume will increase. Initial volume at time t is equal to 0. Initial volume of the vessel was 2 liters. Now final volume at 250 seconds has to be calculated with the help of this result. So final volume is this. Yeah? Perfect. Okay, if this sort of a question comes in your NEET examination, this one is going to be the rank deciding one. It is going to be the rank deciding question. Yeah? Right? I think I'm perfectly clear. If I am perfectly clear, then let me teach you certain concepts first of all. I'll teach you certain concepts. Okay? I'll teach you something. After that, we'll again jump into the questions. My dear students, one topic that was missed in the yesterday's session, that was kinetics of a gaseous. Kinetics of a gaseous first order reaction. Kinetics of the gaseous first order reaction. Kinetics of the gaseous first order reaction. For example, imagine that I've got the reaction in this format. A gas, it gives B gas plus C gas. Imagine rate constant of this reaction is K and it follows the first order kinetics. It follows the first order kinetics. Try to understand what exactly I'm going to say. And this particular reaction, imagine it will be happening in a container basically, right? It will be happening in a container. Initially at time t is equal to 0. Initially at time t is equal to 0, there will be only reactant in the container, right? There will be no product. So if I ask you, how many gases are there in the container initially? There will be only one gas in the container initially. That will be gas A. That will be gas A. Only one gas. Only one gas in the container. That will be gas A at time t is equal to 0. So at time t is equal to 0, whatever is the pressure that is entirely due to A, let's say that pressure is, for example, P0 atm, P0 bar, whatever. So pressure due to B and pressure due to C right now will be 0 because B and C has not got formed yet. B and C has not got formed yet. Okay. Now, my dear students, at time t, when the reaction starts, moles of reactants decrease, moles of product increase. If moles of reactant decreases, that means pressure due to reactant decreases, pressure due to reactant increases, right? Now, treat these pressures in the similar way as you treat moles. Out of P0, subtract X. This will be P0 minus X. 1 mole gives 1 mole, X gives X. 1 gives 1, X gives X. What is this P0 minus X? This is the pressure due to A at time t. This is pressure due to B at time t. This is pressure due to C at time t. Okay? Since it's a first order reaction, a first order reaction takes infinite time to complete. First order reaction takes infinite time to complete. Perfect? Infinite time to complete. It does not undergo completion. So, at time t is equal to infinity. At time t is equal to infinity. At time t is equal to infinity, the reaction would have got completed. What does that mean? That means 100% reactant would have got converted into product. If 100% reactant would have got converted into product, there will be 0 reactant left at t is equal to infinity. So pressure due to reactant will be 0. Pressure due to reactant will be 0. Because entire reactant has got converted. Since 1 mole gives 1 mole, this P0 would have given P0. 1 mole gives 1 mole, P0 would have given P0. Right? Now guys, if I ask you, what is the total pressure? What is the total pressure? What is the total pressure of the mixture at time t? Total pressure of the mixture at time t. Total pressure at time t. Total pressure at time t will be pressure due to A, pressure due to B, pressure due to C. Add them. So P0 minus X plus X plus X. So total pressure here will be P0 plus X. Or you can calculate X from here. X will be nothing but Pt minus P0. X will be Pt minus P0. Why am I doing this? You'll get the answer in some time. If I ask you what is the total pressure at infinity, P infinite, at time t is equal to infinite, what is the total pressure? This plus this plus this, it will be 2 times P0. So from here you can calculate P0. P0 will be nothing but P infinity divided by 2. P0 will be nothing but P infinity divided by 2. P infinity divided by 2. Now guys, there are 2 types of questions asked. There are 2 types of questions asked. What is that? 2 types of questions are asked. Number one, you'll be asked to calculate rate constant of the reaction in terms of P0 and Pt. This is the first question which will be asked. Calculate the rate constant in terms of P0 and Pt. Since it's the first order reaction, so K is equal to 2.303 divided by T. It used to be log of A0 by AT. A0 used to be initial concentration, but here A0 will be initial pressure divided by AT. AT used to be concentration of reactant left at time t. This will be pressure of reactant left at time t, which is P0 minus X. Now guys, you can write it like this: 2.303 divided by T log of P0 divided by P0 minus, what is X? X, I believe we already calculated. How much is that? That is Pt minus P naught. Perfect. Now, a bit of calculation is needed here. It will be 2.303 divided by T log of, it will be P naught divided by 2 times P naught minus Pt. This is your expression of K, which is asked directly. This will be directly asked. These sort of 3-4 expressions will be given. You'll be supposed check which one is the actual value of K. And this is the value of K. This is the expression of K in terms of P naught and Pt only. In terms of P naught and Pt only. Did you get it? Did you get this? Did you get this? This is the first question asked. Second question. Calculate the rate constant in terms of Pt and P infinite. This can be one more question asked. Calculate the rate constant in terms of Pt and P infinite. Since already for this particular reaction you got the expression. Right? The same expression again. 2.303 K is equal to 2.303 divided by T log of P naught divided by 2P naught minus Pt. Was this the expression? 2P naught minus Pt. Yes, this was the expression. But this is the expression in terms of P naught and Pt. What do I need? I need in terms of Pt and P infinite. My dear students, if you look carefully, have I already eliminated P naught in terms of P infinite? Yes. P naught is nothing but P infinite by 2. I can say P naught is nothing but P naught is P infinite by 2. So substitute in the given equation. So K will be nothing but 2.303 divided by T. It is log of, instead of P naught, it's going to be P infinite by 2 divided by 2 times. Instead of P naught, P infinite by 2 minus Pt. So 2 got cancelled. So K here will be equal to 2.303 divided by T. It is log of, this will be P infinite divided by. This 2 comes to the denominator. 2 times P infinite minus Pt. Look at this particular expression. Is this expression in terms of P infinite and Pt? Yes, we converted the same expression in terms of P infinite and Pt. Right? This can be one more question asked. Am I clear? You are not supposed to remember these expressions. You are supposed to make these expressions. Look here, people. I use the stoichiometry here as 1:1:1. If I change the stoichiometry, everything will be changed. Do you want to see how? I think one more example is needed here, right? Otherwise, it won't be clear to you. You won't understand what you are doing exactly. I think one more example is required. So, I'll take one more example. Anything, whatever you feel like taking. Let's say I'm taking a reaction like this. A gas gives 2 times B gas plus 3 times C gas. Imagine it's a homogeneous gaseous phase reaction, right? Okay. Now people, for this particular reaction, what do I need? I need to get the rate constant first in terms of P naught and Pt, second in terms of Pt and P infinite. That is something which I want. Understand? So I'll start with the same procedure. At time t is equal to 0, pressure due to A will be P naught, this will be 0, this will be 0. At time t, pressure due to A is going to be P naught minus X. 1 mole gives 2 moles, X will give 2X. 1 gives 3, X will give 3X. Perfect. At time t is equal to infinity, entire reactant would have got converted. So I'll be left with nothing. Pressure due to reactant is 0. Now entirely it has got converted. 1 gives 2. From P naught you get 2 times P naught. 1 gives 3. From P naught you get 3 times P naught. Do you see how fastly you are doing it now? Yeah? Now, perfect. If I ask you, total pressure at time t will be equal this plus this plus this, which will be 3 plus 2, 5. 5 minus 1 is 4. So P naught plus 4x. Can I eliminate x from here? X will be equal to 1 divided by 4. This is going to be Pt minus P naught. Right? 1 divided by 4 Pt minus P naught. This is your x. Yeah? This is your x. Since you got x, number 1. Number 2, if I ask you, what about P infinite? Total pressure at infinity. This plus this plus this, which will be 5 times P naught. Right? So P naught will be equal to P infinite divided by 5. P naught will be equal to P infinite divided by 5. Now the first question that will be asked, what is that? What is that first question? The first question is calculate the rate constant in terms of P naught and PT. Rate constant in terms of P naught and PT. You know the expression? K is equal to 2.303 divided by T. It is the log of A naught by AT. What is A naught? Initial concentration. Instead of initial concentration of reactant, I'll take initial pressure of reactant. So this is P naught divided by AT. Concentration of reactant left at time T. That means pressure of reactant left at time T. Right? Which is P naught minus X. What is X? X already we have 1 divided by 4. This will be PT minus P naught. Now a bit of calculation is needed. You are done. 2.303 divided by T. Log of, right? Log of. This will be 4 P naught. 4 P naught plus P naught comes out to be 5 P naught, right? So at the end, it's going to be 4 P naught in the numerator. This will be 5 P naught minus PT, right? When you do all the calculations, 4 P naught plus P naught makes it 5 P naught minus PT, and that 4 goes up. So this is your expression of K in terms of P naught and PT. Now, if they are asking you the similar question, calculate K in terms of what? In terms of PT and P infinite. PT and P infinite. What do you have to do? Instead of P naught, you just have to write P infinite by 5, right? So wherever you are saying P naught, replace that with P infinite by 5. Replace that with P infinite by 5. Get the final expression. That's all. Am I clear? Am I clear, people? Let me show you. There was once a question asked from this. Once a question was asked. A gives 2B plus C. The question was asked in AIMS 2019. The question was asked in AIMS 2019. Can you give it a try? Can you let me know just a second? Can you let me know what is going to be the answer of this particular question? Quickly. Quickly, people, quickly. I want everyone to let me know. Can you give it a try? All the answers are given in terms of P naught and PT. All the answers are given in terms of you can solve this. That's what I want. Yeah? Clear? Guys, now you have to be super fast since you got to know how to solve the questions, right? You have to be super fast now. See how fast you are supposed to be. First of all, the reaction is given as A gives 2 times B plus C. Initially at time t is equal to 0, this is P naught, this is 0, this is 0. At time t, this is supposed to be P naught minus X, this will be 2X, this will be X. So PT will be equal to what? This X cancelled, it will be P naught plus 2X. So X from here will be equal to 1 divided by 2 PT minus P naught. PT minus P naught. So K you can calculate as 2.303 divided by T log of P naught divided by P naught minus X. X is what? 1 by 2 PT minus P naught, right? Bus, done. 2.303 divided by T. It is log of. It will be 2 times P naught minus P naught plus P naught. It will be 3 times P naught minus PT. See, is there any expression like this? See, is there any expression like this? This is the expression, right? Done? If you remember the procedure, how do we do it? Like, if you remember the procedure which I showed you a few minutes back, you are definitely going to kill this question. Even any sort of question, whatever stoichiometry they give you, right? But this is the expression in terms of P naught and PT. Anyways, they would have asked the question. They can ask the question in terms of PT and P infinite as well. There you have to replace P naught by P infinite, right? You have to get the relation between P naught and P infinite. And over here, your P infinite will be 3 times P naught. It will be 3 times P naught. So P naught is P infinite by 3, right? So replace P naught by P infinite by 3. Get the answer in terms of PT P infinite as well. I hope I'm clear. I hope I'm clear. Do you want to see questions now, or do you want to see one more? Do you want to learn one more concept, which is level up, which is not asked in NEET, but maybe this year they can ask because level is going to be up. What do you want this time? Do you want to see the questions or the concept first? Do you want to see the questions or concept first? Concept? One more concept. Okay. Try to understand then. Try to understand then. I'm writing the heading as kinetics of parallel first order reaction. I'm not deriving the expressions here. I'll be just giving you the tricks to solve the question. Tricks to solve the questions. Kinetics of parallel first order reactions. Try to understand, guys. Try to understand what exactly I'm going to do. For example, you are seeing the reaction in this format. A gives B, A gives C. Rate constant of this is K1, rate constant of this is K2. Okay? I'm assuming this step is also first order, this step is also first order. I'm assuming this partial reaction is first order, even this partial reaction is first order, right? This kind of the reaction whenever you see, you call this as parallel first order reaction. You call this as parallel first order reaction. The first thing which I'm going to define over here, that is going to be average rate constant of the reaction. Average rate constant of the reaction. That is simply the sum of individual rate constant. K1 plus K2 plus K3. Right? Number one. First point. Average K average is equal to K1 plus K2. Number one. Number two. Number two. Number two. Number two. There are few terms. One is called as average half-life of the reaction. Average half-life of the reaction. One is called as partial half-life of first reaction. One is called as partial half-life of second reaction. This is your first reaction. This is your second reaction. One is called as average half-life of the reaction. One is called as partial half-life. Partial half-life. Instead of K average, can't you write 0.693 divided by average half-life? Okay, of the entire reaction is equal. Instead of K1, you can write 0.693 divided by partial half-life of the first reaction plus this is going to be 0.693 divided by partial half-life of the second reaction. So this dot got cancelled. So first of all, this result is important. 1 upon average half-life of the reaction is equal to 1 upon partial half-life of the first reaction plus 1 upon partial half-life of the second reaction. This expression is again important. Expression important. Where do we use this? You'll get the idea in some time. This is equally important. So two expressions. Now people, in this particular parallel first order reaction, what is the integrated rate equation which we are going to use? If you remember our first order kinetics, K is equal to 2.303 divided by T. It used to be log of A naught divided by AT. This was your integrated rate equation for the first order kinetics. Now guys, since we are talking about parallel first order reaction, so instead of K, you just have to write K average. And instead of K average, you can write K1 plus K2. So this is your integrated rate equation here. This is your integrated rate equation here. Number 2. Number 3. This is your integrated rate equation here. At the same time, if you remember, in the last session, I gave you one expression for the first order kinetics. AT is equal to A naught e raised power minus KT. Instead of K here, you have to write K average. So your expression becomes AT is equal to A naught e raised power minus. Instead of K, K average. K average here is nothing but K1 plus K2, right? Multiplied by T. This becomes one more form of the integrated rate equation for the parallel first order reactions. Okay, right? Guys, remember these expressions. Maybe you would not have studied all this in your schools, coachings, wherever. Okay, but there is high probability that the question is going to be asked in NEET from this particular concept which I'm teaching you right now. Okay. Now, people, first of all, in the parallel first order reaction, whenever you see this sort of a reaction, right, in which both the steps are first order, you call this as parallel first order reaction. The first expression is K average, K1 plus K2. Second expression, 1 by average half-life is equal to 1 by partial half-life of first reaction plus 1 by partial half-life of second reaction. Number 3, K average is equal to 2.303 divided by T log of A naught by AT. Next, A naught is equal to, AT is equal to A naught e raised power minus K average into T. These are few expressions which you need to remember. Number 1. Number 2. Imagine at time T is equal to 0. Imagine at time T is equal to 0. What do we have? What do we have? Let's assume we have got A naught moles of reactant at time T is equal to 0 in the container. Since this reaction has to happen in the container, right? I'm assuming at time T is equal to 0. How many moles of reactant do we have? A naught, for example. These are the moles of reactant, right? Okay. Your B and C combinedly I'll be calling as products. B and C combinedly I'll be calling as product. So your product contains B and C. So at time T is equal to 0, how many moles of product will be there? Since the reaction has not started yet. Since the reaction has not started yet. So moles of product will be 0. Moles of product will be 0, right? I'm assuming. I'm taking a term here. That's X. I'm writing a term here. That's X. Let's say X represents number of moles. X represents number of moles of reactants. Number of moles of reactants which dissociate, which break down into products. Which dissociate into products. I'm defining a term. X. What is X? X are those moles of reactants which are dissociating into products. Which are dissociating into products. Right? X are those moles of this reactant which are dissociating into products. Now, my dear students, try to understand. At time T is equal to 0, the initial moles of reactant was A naught. Initial moles of product were 0. Perfect. The first question that will be asked. What will be the moles of B? What will be the moles of B or moles of C at time T? Moles of B or concentration of B at time T? Moles of C at time T or concentration of T at time T? This will be the first question. How many moles of B have got formed at time T? Right? See, it is evident. Initially, A naught moles, this is 0. Now, as the reaction proceeds, moles of A will be decreasing. Moles of A will be decreasing. And moles of product will get formed. Moles of product will get formed, which includes B and C. Now, if they ask you how many moles of B or C have got formed at time T, or they can ask you what is the concentration of B and C at time T, or if they ask you what is the pressure of B and C at time T, how do you do that? How do you do that? Remember one simple trick over here. Moles of B, concentration of B or pressure of B at time T will be equal. First, you will be writing K1 divided by K2. First, you will be writing K1 divided by K1 plus K2. Right? Now, use the stoichiometry. 1 mole of A gives 1 mole of B. X moles of A gives X moles of B multiplied by X. This particular term will give you the moles of B or concentration of B or pressure of B at any time T. Number 1. If you are supposed to calculate concentration of C at time T, it will be equal to what? As per this expression, K2 divided by K1 plus K2. Okay, now 1 mole of A gives 1 mole of C. So X moles of A would have given X moles of C. Done. This will be one question asked. This will be one more question asked. I'll show you the examples as well. But before that, few more things. My dear students, if you divide these two equations, what do you get? If you divide these two equations, I'll be getting something like this. Concentration of B at time T divided by concentration of C at time T will be equal to X cancel, K1, K2 cancel. It will be K1 divided by K1 plus K2. It will be K1 divided by K1 plus K2. It will be K1 divided by K1 plus K2. Okay. Now, I'm asking you one simple thing, which you need to give it a thought. At time T, what all things will be there in the container? At time T, you'll find some reactant left and product got formed. What is product? Product is B plus C. Product is B plus C. Product is B plus C. If they ask you, what is the percentage of B in products? What is the percentage of B in products at time t? What is the percentage of B in products? How do you do that? If they ask you, what is the percentage of C in products at time t? Product is B plus C. B plus C is your product. So at time t, in the container there'll be B as well as C as the product, right? So what is the concentration of, what is the amount, what is the percentage of B in the products? What is the percentage of C in the products? How do we do that? Percentage of B in the products. Percentage of B in the products. See what is in front of it? K1. So first of all, you write K1 divided by K1 plus K2 multiplied by 100. Done and dusted. Percentage of C in the products. What is in front of C? K2. Write K2 divided by K1 plus K2 multiplied by 100. So these are again two more questions which can be asked. These are again two more questions which can be asked. Percentage of B in the products and percentage of C in the product. Am I clear? Am I clear? Am I clear with all these things? Tell me, people, quickly. Am I clear with all these things? I need to show you some questions. 1-2 questions I'll show you from this so that you'll understand it. If a question is asked from this particular part also, you should be able to solve all those questions, guys. All those questions. Because I've told you already, I'm not going to keep any stone unturned here. Every single thing I'll be discussing. All the types of the questions we shall be discussing. Perfect. Amazing. All right. This was your part 1, wherein the stoichiometry involved was 1:1:1. Okay, stoichiometry was 1:1:1. Now, guys, if I change the stoichiometry, what do you think will happen? If I change the stoichiometry, what is going to happen? I believe you're studying all this for the first time, is that? And guys, by the way, these expressions which I gave you, they have got long derivations. No need to remember them. No need to remember them. No need to remember them. Now see, guys. For example, I'm taking the reaction like this. Let's say the reaction is like this. A gas, try to understand very carefully. Use 2B gas. Use 2B. And here you have got 3 times C. Imagine this my reaction. I'm assuming both the steps are first order, so it's a parallel first order reaction. It's a parallel first order. Now the same process. Initially at time t is equal to 0, there'll be only reactant in the container, so A naught. Product is B plus C, which will be 0. Right? Now, at time t, the concentration of reactant left is 80. Or the amount of reactant left is 80. Or the moles of reactant left is 80. Now, I'm defining a term. What is that? X. What is X? What is X? These are the moles. These are the moles of reactant. These are the moles of reactant dissociated into products. These are the moles of reactants dissociated into products. If I ask you, how do we get it? You'll say initially I had A naught moles. At time t, there are 80 moles. Initially I had A naught. I'm left with 80. So A naught initially minus left out. So X is nothing but A naught minus 80, right? X is nothing but A naught minus 80. Perfect. A naught minus 80. Perfect. Let's say rate constant of this particular one is K1. Rate constant of this particular one is K2. Average rate will be K1 plus K2. Average rate will be K1 plus K2. And already 80 value you know. 80 value you know. It is A naught e raised power minus K1 plus K2 into T. Right? So you can get expression for X as well here. A naught minus, this is A naught e raised power minus K average multiplied by T. So A naught take common, X value you can get from here. It is A naught 1 minus e raised power minus K1 plus K2 multiplied by T. Perfect. This is the value of X here. This is the value of X here. Same thing you could have done here also, right? At time t, amount of reactant left is 80. So this X would be equal to what? it will be equal to A naught minus AT, right? So finally, it will be A naught 1 minus e raised power minus K1 plus K2 multiplied by T. Perfect? Just to let you know. Just to let you know. Now, guys, what is the first thing which we'll be doing? If I ask you at time T, how many moles of B, what is the concentration of B, or what is the pressure of B formed? At time T. At time T. How you are going to do it? How you are going to do it? First of all, you'll start with K1. So it is K1 divided by K1 plus K2. Then use the stoichiometry. 1 mole gives 2 moles. So X would have given 2X. Perfect. Concentration of C, which has got formed at time T. It is going to be K2 divided by K1 plus K2. Now, 1 gives 3. So X would have given 3X. Perfect. You got 2 equations. You got 2 equations. This topic is boring, but it will be asked. So understand it. Remember it. Okay? There's nothing boring or interesting in your examination. All are equally important. If you divide these two, concentration of B at time T divided by concentration of C at time T will be equal. You'll get it as 2 times K1 divided by 3 times K2. 2 times K1 divided by 3 times K2. Okay? 2 times K1 divided by 3 times K2. This was your first expression from which question will be asked. This is your second expression from which question will be asked. And this is your third expression from which question will be asked. Now, at time T, if you talk about products, if you talk about your products consists of B and C. Your products consists of B and C. If I ask you, what is the percentage of B in products at time T? What is the percentage of B? What is in front of B? 2 times K1. You'll write 2 times K1 divided by this plus this. It will be 2 times K1 plus 3 times K2. And you'll be at the end multiplying it with 100. Similar, percentage of C in the products. Percentage of C in the products. In front of C, what do you see? It is 3 times K2. Divided by what? 2 times K1 plus 3 times K2 multiplied by 100. Right? These are 2 more questions which will be asked from this parallel first order reaction. From this parallel first order reaction. I hope I am clear to all of you. Is it clear now? Is it clear, people? Okay. Perfect, guys. I'm giving you a question on this. Let's see if you can solve this or not. See what kind of questions will be asked from this. The question is, we are given with a reaction. A gives B, A gives C. Its rate constant is K1, its rate constant is K2. Okay? And as per the question is concerned, K1 is what? K1 is 0.693 minute inverse. And your K2 is 0.1386 minute inverse. 1386 minute inverse. Perfect. I'm asking you to calculate the percentage distribution. I'm asking you to calculate the percentage distribution of B and C in the products. Can you give it a try once? Quickly. Can you give it a try once? Can you solve this question on your own quickly? You should be, guys. You should be able to. Solve it quickly. Percentage distribution of B and C. Stoichiometry is 1:1:1. So I'll say percentage of B in the products will be equal to, it's going to be K1 divided by K1 plus K2 multiplied by 100. Okay, what is K1? 0.693. What is K1? 0.693 plus what is K2? 0.1386 multiplied by what? Multiplied by 100. If you take 0.693 common in denominator and numerator, 0.693, 0.693 cancel. This will be 1, this will be 2 multiplied by 100. So 1 by 3 into 100 comes out to be almost 33%. So percentage of B in the products is 33%. If percentage of B in the products is 33%, that means percentage of C will be 100 minus 33, approximately 66%. Am I clear? Can you solve this sort of equation? Quick. Yes? Right, people? Okay. One more question I'm giving you here. Let me see if you can do this or not. One more question. I'm giving you the reaction A gives 2B and A gives 2C. Rate constant here is K1, rate constant here is K2. Okay, as per the question, it's mentioned that K1 divided by K2 is equal to 1 by 2. K1 divided by K2 is equal to 1 by 2. Okay, K1 by K2 is equal to 1 by 2. The question says, on starting with, I'll write it over here. On starting with 2 moles of A. On starting with 2 moles of A. On starting with 2 moles of A. Calculate the total moles. Calculate the total moles after 75% completion. After 75% completion. Can you give it a try? It's a good one. It's a good one. Can you solve this? You are starting with 2 moles of A. You have to calculate the total moles which are present in the container after 75% completion. Someone is saying, sir, how 0.13 is equal to 2? What are you saying? How 0.13 is equal to 2? What does that mean? How 0.13 is equal to 2? Wow. Then I should say 2 plus 2 is equal to 5. I can say something like this. Right? How 2 plus 2 is equal to 5? Chalo, solve this question quickly. Solve this question quickly. Solve this question quickly. First of all, you are starting with, if you look at the question carefully, you are starting with how many moles of reactant? You are starting with 1 mole of reactant, I think, or 2. You are starting with 2 moles of reactant. So moles of product, which involves B and C, that will be 0. That will be B and that will be 0, right? Right? That will be 0. Okay. Now, when 75% reaction gets completed, 75% reaction gets completed means 75% of the reactant gets dissociated into products. So what is X? X is 75% of 2. That will be 1.5. So these are the moles of reactants which dissociate into products. Right? These are the moles of reactants which dissociate into products. Now it's clear. It's clear. I started with 2 moles, out of which 1.5 are getting dissociated into products. So I'll be left with 2 minus 1.5 is 0.5. So basically when 75% reaction gets completed, how many moles of A are present in the container? There are 0.5 moles of A in the container. Now, product would have also got formed. It's evident product would have also got formed. Right? Product also would have got formed. Now, if I ask you how many moles of B would have got formed at 75% completion, moles of B formed at 75% completion, moles of B formed at time t, how do you do that? K1 divided by K1 plus K2. K1 divided by K1 plus K2. Use the stoichiometry. 1 mole gives 2 moles. From X you get 2X. So this will be 2X. I hope I'm clear. So K1 divided by K1 plus K2. It is 1 by 2. So it has to be 1 divided by 1 plus 2 into 2 times the X. What is X? X is 1.5. X is 1.5. So this is 3. 3 by 3 is 1. So you got to know that how many moles of B have got formed after 75% completion? 1 mole of B has got formed. 1 mole of B has got formed. If I ask you how many moles of C have got formed at 75% completion? At 75% completion, that will be equal to how many moles of C? How many moles of C? K2 divided by K1 plus K2. K2 divided by K1 plus K2. Now, 1 mole gives 2 mole. 1 mole gives 2 moles. X will give 2X. Okay. This will be 2 divided by 1 plus 2 and multiplied by 2 times X. X is 1.5. So this is 3. 3 2s are 6. 6 divided by 3 is 2. So 2 moles of C also have got formed. Now, the question says how many total moles are there in the container at 75% completion? Total moles in the container when 75% reaction has got completed. When 75% reaction has got completed, there will be some moles of reactant which are left, which are 0.5. And how many moles of B and C have got formed? 1 mole of B has got formed and 2 moles of C has got formed. So in total, there will be 3.5 moles present in the container when 75% reaction would have got completed. Am I clear? Am I clear, people? Am I clear? Notes for the yesterday session I've already shared. Perfect. So this was one concept, right, which I wanted to share with you. I believe it's clear. Now let's move ahead. Chalo, give this question a try now. Give this question a try now. Quickly. Give this question a try now. A student has studied the decomposition of gas AB. Decomposition of gas AB. Right? From the following data. The order of the reaction is. We are supposed to calculate order of the reaction. Okay? This is the pressure of your reactant and this is your half-life. Right? Pressure of the reactant, half-life. Guys, do you remember in the last session I gave you one expression? T half 1 divided by T half 2 is equal to A naught 1 divided by A naught 2 whole raised power 1 minus n. Do you remember this expression where n is the order of the reaction? Where n is the order of the reaction? Perfect. A naught, A2. A naught, you can call it as concentration, you can call it as pressure of reactant, concentration of reactant, moles of reactant, whatever. You can call it as pressure of reactant, concentration of reactant, moles of reactant, whatever. Okay. So let's call this as initial half-life, T-1. Let's call this as T half 2. Okay. Let's call this as A naught 1. Let's call this as A naught 2. Now use the expression. T half 1 is 4. T half 2 is 2. Right. A naught 1 is 50. A naught 2 is 100. Whole raised power 1 minus n. So this is 2 is equal to 1 by 2 raised power 1 minus n. Correct? Or I can say 2 is equal to 2 raised power n minus 1. Just reverse it. So what can we conclude from here? N minus 1 is equal to 1. which tells you n is equal to 2. What was n? N was the overall order of the reaction, which is 2. Am I clear with this? Am I clear with this? You got it? We assumed that the order of the reaction was n, right? Order of the reaction was n. And this was one expression which I gave you particularly yesterday, right? No doubt. A naught, it represents the concentration of reactants, it represents the pressure of reactants, it represents the moles of reactants, whatever is given, right? You can take that. Yeah? You can take that. I'm sure it's clear to everyone. I'm sure it's clear to everyone. Okay? See, this is one theoretical question. This is something which you can answer on your own. Is it done, people? Is it done? An increase in the concentration of reactant. If you increase the concentration of reactant, basically you are increasing the number of reactants. If number of reactants are increasing, collisions will increase. If collisions are increasing, what does that mean? Collision frequency will increase. Collision frequency will increase. You should know it also. Okay, you should know it. What about this particular question? What about this particular question? Quickly. The rate of the chemical reaction doubles for every 10 degree. Okay, if the temperature is raised by 50 degree, the rate of reaction increases by about, I gave you an expression yesterday. R2 divided by R1 is equal to 2 raised power delta T divided by 10. Do you remember this? So R2 will be equal to R1. It will be 2 raised power delta T, change in temperature, raised by 50. So 50 divided by 10, that's 5. R2 is equal to 2 raised power 5 times R1, which is 32 times R1. So rate increased by 32 times. Rate increases 32 times. Yes? Simple expression I gave you yesterday. Yeah? Perfect, guys. Can you solve this particular question? Similar sort of question. Similar sort of question. Similar sort of question. In a zero order reaction, for every 10 degree rise in temperature, rate is doubled. If the temperature is increased from 10 degree to 100 degree, then rate of reaction will be, you know already, R2 is equal to R1. Again, the similar type of the equation. It is delta T divided by 10. So R2 will be nothing but R1, 2 raised power. Delta T, change in temperature. Final minus initial is 90. 90 divided by 10 is 9. So R2 is equal to 2 raised power 9 times R1. What is 2 raised power 9? Check it out. That will be 256, I think. Or 512. 2 raised power 9. Is it 512 or 256? Whatever, check it. Okay. What do you think about this particular question? Quickly. What about this particular question? You have got the reaction A gives B. Enthalpy of reaction is given. Enthalpy of the reaction is given as negative. That means the reaction is what? Reaction is exothermic. If it is exothermic, energy of products will be less than that of energy of reactants, right? Energy of products will be less than that of reactants. Over here, product has got more energy than reactants. Over here, same. Over here, more. Over here, less. B is the correct answer. Yes? B is the correct answer. B is the correct answer. Right? B is the correct answer. This is one more asked question, guys. Can you give it a try? One more asked question. Quickly. Solid people, quickly. See, it's a very simple question. If you remember in the last session, I gave you an expression. When I was teaching you collision theory, I told you your delta H is nothing but it is activation energy of forward reaction minus activation energy of backward reaction. This is something which I gave you, this expression, if you remember. As per the question, you have got the reaction X gives Y, which is exothermic, right? Enthalpy change, delta H. Since it's exothermic, so delta H has to be negative. Delta H has to be negative, so it is minus 135 kilojoules. It is minus 135 kilojoules per mole. Perfect. As per the question, activation energy for the reaction, for conversion of X into Y. So that means X into Y means activation energy of forward reaction. That's given to me as 150 kilojoules. And we are supposed to calculate activation energy of backward reaction, in which Y gives X. So EAB is to be calculated. So all the parameters are basically given, right? Delta H is minus 135, EAF is 150, and what is EAB? That's something which you are supposed to calculate. So my dear students, EAB will be equal to 150 plus 135. The value will be 285 kilojoules per mole, right? Be careful with these sort of questions. Okay? You have to look whether the reaction is endothermic, exothermic. Follow this particular result always. Accordingly, take the sign of delta H. If the reaction is exothermic, delta H has to be negative. If the reaction is endothermic, delta H has to be positive. Okay? Perfectly done. Did I give you this result in the last session when I taught you the Arrhenius equation? I gave you this result, if you remember, when I taught you the Arrhenius equation. Ln of K2 divided by K1 is equal to EA divided by R, T2 minus T1 divided by T1 T2. This is the result which we discussed in the last session, if you remember. So mark your option directly. People are saying B. Why it will be B? Here you have got log. If it is log, then in the denominator it has to be 2.303. So it has to be ln. It has to be ln. It has to be ln, right? It has to be ln. Okay? This is your result here. This is your result here. Check the yesterday's session, guys. I have derived this particular result, right? I've given it to you. Maybe I would have taken plus here, and here I would have written 1 by T1 minus 1 by T2. That could have been the only change. That could have been the only change. NEET 2019. What do you think about this one? NEET 2019. What do you think about this one? What do you think about this one? What do you think about this one? For the reaction, activation energy is 0. And the rate constant at 200 Kelvin. When the reaction is carried out at 200 Kelvin, right? Its rate constant is equal to 1.6 into 10 raised power 6 second inverse. The rate constant at 400 Kelvin will be. At 400 Kelvin, what will be the rate constant of the reaction? You've got the reaction whose temperature are changing. So what will happen to its rate constant? Since the reaction which is given to us, that is your basically, it has got activation energy 0. If you see, K is equal to A E raised power minus EA divided by RT. If activation energy is 0, anything raised power 0 is 1. So K is nothing but A, right? Over here, do you see any activation energy? No, it is 0, right? Do you see any temperature here? No. So that reaction whose activation energy is 0, is that temperature dependent or independent? That reaction whose activation energy is 0, is that temperature dependent or independent? Temperature independent. So if you change the temperature, if you change the temperature, is the rate constant going to change? Rate constant is not going to change. It will still remain 1.6 into 10 raised power 6 second inverse only. Am I clear with this? Right? So on changing the temperature, rate constant is not going to change for that reaction whose activation energy is 0. I hope I'm clear. NEET 2015. NEET 2015. Activation energy of the reaction can be determined from the slope of which of the following graphs? Slope of which of the following graphs? Slope of which of the following graphs? Be careful. Be careful. Be careful. You know, your ln of k is equal to ln of a minus EA divided by R multiplied by 1 by T. This is the equation which I gave you yesterday, right? And my dear students, if you plot a curve between ln k versus 1 by T, right? If you plot a curve between ln k versus 1 by T, this is ln k for example, and this is 1 by T. So this is y is equal to minus mx plus c. Minus mx plus c, it's a straight line. And its slope will be nothing but minus EA divided by R, right? So the slope of ln k versus 1 by T from this particular curve, right? From this particular curve's slope, you can get the activation energy of the reaction. So it has to be option A. Okay, it has to be option A. It has to be option A. It has to be option A. Look at this particular question quickly. Look at this particular question quickly. Calculate the activation energy of the reaction in kilojoules per mole and kilocalories per mole. You are given with the graph log k versus 1 by T. If you remember in the last session, I've told you log k versus 1 by T. Its slope will be what? Its slope is minus EA divided by 2.303 R. And slope is nothing, that is tan of theta. Tan of theta. You know, theta is tan inverse minus 3. So tan of theta will be minus 3. Right? Tan of theta will be minus 3. So I can say minus minus got cancelled. And EA is equal to 2.303, right? 2.303 multiplied by 3 multiplied by R. So I'll say EA is equal to, this is 6.909 R over here. Perfect. Now, you have got two questions to solve basically. One, you have to calculate activation energy in kilojoules per mole. At that time, what I'll be doing? I'll be taking the value of R in joules, 8.314 joules per Kelvin per mole. But I want in kilojoules, so I'll be dividing with 1000 as well. The final answer will be here in kilojoules per mole. In the second question, the value of R has to be taken in calories, which is 2 calories per Kelvin per mole. But I want the overall answer in what? Kilocalories, right? Dividing with 1000, so it is kilocalories per mole here. Perfect. So I believe it is now the matter of calculation, and you can accordingly solve your question. Okay. Perfect. Look at this particular question. It's again a simple question. Again a simple question. Again a simple question. Slope of ln k versus 1 by T. Ln k versus 1 by T slope is minus EA divided by R. That is minus EA divided by R. And this slope is given to us as minus 5 into 10 raised power 3. Guys, be careful whether it is mentioned as log k or ln k. If it was log k, then slope was minus A by 2.303 R. But here it's ln k, so the slope is minus EA divided by R. Okay, so minus cancel. Right? What do we have to calculate? Activation energy. Activation energy is nothing. It is 5 into 10 raised power 3 multiplied by R. We have to get the answer in kilojoules. So what do you need to do? 5 into 10 raised power 3. R will be 8.314 joules per Kelvin per mole divided by 1000. And the final answer will be in kilojoules per mole because I divided with 1000. Just done and dusted. Right? 8 5s are 40. So approximately this is the answer B. Yeah, approximately B is the answer. By the way, this question which I showed you, it was actually asked in NEET 2021. This question was asked in your NEET 2021. Look at this particular question. I hope the screen is visible to you. Is the screen visible now? NO2 required for the reaction is produced by the decomposition of this, okay? If the initial concentration of N2O5, initial concentration of N2O5 is given, and it is 2.75 after 30 minutes, the rate of formation of NO2. Simple. Rate of formation of NO2. First of all, if you write your rate, differential form of rate for this particular reaction, it will be minus 1 by 2, change in the concentration of N2O5 divided by what? Divided by delta T. You can write it in terms of what? You can write it in terms of NO2 as well, which will be plus 1 divided by 4, change in the concentration of NO2 divided by delta T. Perfect. What do we have to calculate? We have to calculate rate of formation of NO2. So take this 4 here. It will be change in the concentration of NO2 with the plus sign in the beginning divided by delta T has to be equal. 4 by 2 is 2. So it is minus times 2, change in the concentration of N2O5 divided by what? Divided by delta T. This term is what you call as the rate of formation of NO2, if you remember. This is your rate of formation. Rate of formation of what? NO2. So you can calculate rate of formation from here. It will be minus 2. Change in the concentration of N2O5. Change in the concentration of N2O5 is final concentration of N2O5 minus initial concentration, right? Final is nothing but 2.75. Initial is 3 divided by time interval is 30 minutes. Just solve this, get the answer. That's all. Yes? Right, people? Isn't the question clearly visible? Oh my God. Just a second, let me check it through phone. Guys, what are you telling me? It's clearly visible. I can read it from my phone. NO2 required for the reaction is produced by the decomposition of NO2, N2O5 in CCl4 as per equation. It's clearly visible. Right? It's not that. It's not that blur. It's not that blur. So please. It's not that blur. Solve this one quickly. I think we have solved this one a few minutes back only. In that question which I gave you, there it was mentioned as the gas was AB. Here it is AB3. That's it. No change. Which equation you are going to use? T half 1 divided by T half 2 is equal to A01 by A02 whole raised power 1 minus n. From there you can get the n value. And I remember its answer now. It's 2. We have solved it. We have already solved it, right? Look at this question. A reaction is given. A gives B. This reaction is a zero order. It is a zero order. Half-life of this reaction is 50 minutes. Half-life of this reaction is 50 minutes. It is 50 minutes. The time taken for the concentration of A to reduce to 1/4 of its initial value. So first of all, it's a zero order reaction, right? A gives B. As per the question, it is a zero order reaction. If it is a zero order reaction, its half-life is also given. T half is equal to 50 minutes. T half is equal to 50 minutes, right? The time taken for the concentration of A to reduce to 1/4 of its initial value. Imagine initially the concentration of A was A0. I need to calculate the time in which the concentration of A reduces, right? Concentration of A reduces from A0 to A0 by 4, right? So the concentration of reactant left here is A0 by 4, which is the concentration of reactant left represented by AT. So this is my given data. This is my given data. Simple. Calculate the time taken for the concentration of A to get reduced to. It is not reduced by. It is reduced to. The concentration of A left has to be A naught divided by 4. Now what I'll be doing exactly? First of all, half-life is nothing but A naught divided by 2K. So A naught by 2K is equal to 50. A naught is what? Is A naught given? Is A naught given? Let me check it. The above reaction of the half-life of this reaction is 50. The time taken for the concentration of A to reduce to 1/4 of its initial value is okay. So you can take A naught as 1. You can take A naught as 1 here. 1 molar, right? So this will be 1 divided by 4. Perfect. So this will be K is equal to 1 divided by 100. 1 divided by 100 moles, liter inverse, minute inverse. Or you could have kept A naught as such. Does not make any difference. Okay. Now, you know, your AT is nothing. It is A naught minus KT for the zero order. What is your AT? AT here is A naught by 4. A naught by 4 means 1 by 4. A naught by 4 means 1 by 4. A naught is 1. K is here 1 divided by 100. And T, you have to calculate. Correct? T, you need to calculate. So from here, what is the value of T which you have got? It is 100 minus T divided by 100. So 100 divided by 4 is 25. So 25 is equal to 100 minus T, which tells you that T is equal to 75. And since everywhere you are using minutes, so you got to know T1 by 4. T1 by 4 is equal to what? You got to know your T is basically here 75 minutes. So after 75 minutes, the amount of reactant will be reduced to 1/4 of its initial value. Okay? Dharani, you cannot use that formula here because that I have given for first order, but this is zero order which is given. So 75 minutes is the correct answer of the question. Good job. Okay. This question you should be solving in less than 10 seconds. This question you should be solving in less than 10 seconds. Less than 10 seconds. I mean it. I mean it, people. Less than 10 seconds it has to be solved. Less than 10 seconds it has to be solved. For a first order reaction, A gives B. Half-life is given. Time taken to complete 75% of the first order reaction. Half-life is given. Yesterday I've told you, half-life is given. Half-life is how much? 30 minutes. And I've told you already, time taken to complete 75% of the first order reaction is equal to 2 times the half-life, right? So 2 multiplied by 30 minutes comes out to be 60 minutes. This is the time taken to complete 75% of the reaction. Tell me what is the time taken to complete 99.9% of the same reaction? Time taken to complete 99.9. Quick. Time taken to complete 99.9 of the reaction. What will be the answer then? 300. Perfect. Tell me, time taken to complete 87.5%. 87.5%, quick. 87.5%, quick. That'll be 3 times, right? Can you solve this one? Similar type, decomposition of X exhibits a rate constant. Rate constant of the reaction is given as 0.05 micrograms per year. Okay. How many years are required for the decomposition of 5 micrograms of X into 2.5? Right? Can you solve this? It's a simpler one. How many years are required for the decomposition of 5 micrograms of X to 2.5? What does that mean? 5 to 2.5. That means 50% completion. 50% completion means you are supposed to calculate half-life. What is half-life? A naught divided by 2K for the zero order. Right? How come I got to know it is a zero order? Check the rate constant unit. It is same moles per liter per second type. Right? So it has to be A naught. A naught is the initial amount. How much is the initial amount? 5 microgram divided by 2 times. What is K? K is 0.05 microgram per year, right? So this term cancel, right? So it'll be how much? The answer is going to be 50 years. The answer is going to be 50 years. I hope I'm clear. I hope I'm clear. Look at one more question. And this is the last question of chemical kinetics. After this, we'll take break. And then after the break, we shall be starting the electrochemistry questions. The rate constant of the first order reaction. You are given the expression. A reaction follows this equation. Ln K is equal to 33.24. Is it 33.24 or 3324? Chalo, we'll take it as 33.24. 33.24 minus 2 into 10 raised power 4 into 1 divided by T. A reaction is following this particular equation. We have to calculate activation energy. Have you seen any equation of Arrhenius in this format? Ln of K is equal to ln of A minus EA divided by R multiplied by 1 by T. If you compare these two equations, your E divided by R value is coming out to be what? Your E, A divided by R value from here is coming out to be 10 raised power 4. So your EA will be nothing but 2 into 10 raised power 4 multiplied by R, right? R value is 8.314 joules per Kelvin per mole. Divide it with 1000, then your final answer will be in kilojoules per mole. Now it is just a matter of calculation. That's all. Is this one. What do you think about this particular equation? Galvanic cell or voltaic cell? It is a device which is used to convert chemical energy produced in dash reaction into dash energy. What do you think about this one? Quickly, everyone. Everyone, quickly. Look at the options carefully. Look at the options carefully, guys. You need to look at the options carefully. Don't make mistake in this silly question. Galvanic cell is the one which converts chemical energy produced in a redox reaction. Into what? Into electrical energy. So redox electrical. So it has to be option C, which has to be the correct answer of this particular question. Okay? Tell me the answer of this particular question. Something which we discussed in the last session. Very simple and basic. In Daniel's cell, what happens? Which electrode is anode and which is cathode? Quickly, everyone. In your Daniel's cell, your zinc electrode that works as anode and copper electrode that works as cathode, right? Correct, people? Your zinc electrode, it behaves like the anode, and copper electrode, it behaves like the cathode. Okay, one more theoretical one. The potential difference between the electrodes, okay? The potential difference between the electrodes in a galvanic cell. Between the electrodes, he's asking. He's not asking about the potential difference between the rod and the solution. Potential difference between the electrodes. What do you call as? You call that as cell potential. You call that as cell potential. Okay? And the maximum cell potential when the cell is not in use, maximum potential difference when the cell is not in use, what do we call that as? That is called as EMF. Right? That's called as EMF. So, remember this particular question as well. What about this one? Again a theoretical one. In a galvanic cell, anode is on the left hand side and is a positive electrode. Is that? Cathode is on the left side. Anode is on the left side and the rod carries negative. Yes. Cathode is on the right side and the rod carries positive. Something which we discussed yesterday. If you remember, on the zinc rod, electrons were being accumulated, due to which it was negative. From the copper rod, electrons were being snatched, right? Due to which copper rod got positive. So it's one, again, simple question. Tell me about this one. The potential which develops between the rod and the electrolyte. What do you call that potential difference as? The potential difference, the potential which gets created between the rod and the solution, between the rod and the electrolyte. What do you call that as? Electrode potential. Correct? You call that as electrode potential. Again, this is something which you should know. In electrochemical cell, an electrochemical cell stops working after some time. Right? Something which I showed you yesterday. Your galvanic cell, it stops working in between. Why is that? Why is that? What is the reason? This is something again which is discussed in the last session. Because cell reaches equilibrium in between. Equilibrium is established in the cell. What does that mean? That means the potential of both the electrodes, the electrode potential of both the electrodes, it becomes equal. Therefore, potential difference is zero and current is zero, right? Electrode potential of both the electrodes becomes equal. And that stage in the cell is something which you call as equilibrium. At equilibrium, your E cell is zero. Your delta G is also zero. Something which we discussed in the last session. Okay? Look at this particular question. Again, theoretical. Again, theoretical. Which of the following statements are correct? Reduction for the galvanic cell. Reduction is taking place at cathode, oxidation at anode. Absolutely right. Reduction at cathode, oxidation at anode. Reduction at anode? No. Electrons flow from anode to cathode. In your galvanic cell, the moment of the direction of electrons is from anode to cathode, right? Right? Electrons flow from cathode to anode. No, current flows from cathode to anode. So 1 and 3. 1 and 3. Yes, these were the conclusions which I gave you in the last session regarding the galvanic cell. Okay. If you remove the salt bridge, what will happen? If you remove the salt bridge, what will happen? Liquid junction potential gets created, right? And the overall potential difference between the electrodes, that drops to zero. Cell stops working after some time, right? Cell stops working after some time. Okay? Cell will stop working after some time if you remove the salt bridge. Perfect. What do you think about this one? In a galvanic cell, which of the following statement are correct related to salt bridge? Salt bridge completes the internal circuit if you use two containers, right? If you use two containers. It maintains the electrical neutrality of anodic and cathodic compartment. Absolutely right. Smooth flow of current. Absolutely right. Because if you remove salt bridge, voltage potential difference drops to zero. That means all are correct. Yes. These are again the conclusions, the theoretical questions which can be asked from the Daniell cell. Okay. Standard hydrogen electrode, SHE. Standard hydrogen electrode. We say its electrode potential is zero, right? SOP, SRP of hydrogen electrode, that is zero. And that is something which we assume, correct? I told you that in the last session. That is something which we assume. We assume the electrode potential of SHE as zero. Okay? That is something which is assumed. So option 4 is the one which is correct. Look at this particular question. Look at this particular question. Think over it. We have got two half cells, two electrodes. One having the reduction potential One having the reduction potential of minus 0.76 volts, another one having the reduction potential of minus 0.13 volts. If you connect these two cells externally and internally, what do we get? We get a complete cell, complete cell. Now, which of the following is correct? My dear students, you are given with the reduction potentials. Now, which one has got more reduction potential? This is more. The one which has got more reduction potential, that undergoes reduction easily, right? And reduction happens at cathode. So, this one behaves like the cathode. This one behaves like the anode. Now, select the answer. Electrode potential of half cell having minus 0.76 works as cathode. No. Electrode potential of half cell minus 0.76 serves as anode. Yes, it's correct. It is serving as anode. Electrode potential of the half cell having potential minus 0.13 serves as anode. No. Electrode potential of the half cell having minus 0.13 potential. Electrode potential. It serves as cathode. Yes, it's correct. So it's 2 and 4. It is 2 and 4 which is correct, right? It's option 2. It is option 2. It is option 2. We have to calculate E naught cell. We have to calculate E naught cell. Right? We are given with the cell and its standard EMF is to be calculated. How do we calculate standard EMF? You should know it by now. E naught cell is equal to E naught of cathode minus what? Minus E naught of anode. We use SRP of this as well as SRP of this. We take SRP of cathode as well as SRP of anode here. Perfect. Now, your zinc electrode is your cathode. This is your cathode and this is your anode. Perfect. Now look at this particular value. 0 to plus 2. 0 to plus 2. Increase. Increase means oxidation. So, this is your SOP. But what do we need? We need SRP. Its SRP is minus 0.76. Right? This is also SOP. What do we need? SRP. SRP will be plus 0.34. Now, your SRP of cathode is minus 0.76 minus SRP of anode. SRP of anode is plus 0.34. Perfect. The value will be minus 1.1 volts. Is it clear? Is it clear, people? Is it clear to everyone? This was minus 0. This is minus 0.34. This is SOP. So SRP will be plus. SRP will be plus. Okay? Or did I do any mistake here? Did we do any mistake here? Just a second. Cathode is... wait. What did I do here? Wait. This is serving as anode. This is serving as cathode, right? Zinc is serving as anode. This is cathode. Now you can check it. I'm sorry. Your cathode is this is 0.34 minus your anode is minus 0.76. You are correct. It is plus 1.1 volt. It is plus 1.1 volt. Yeah? Right. Guys, I can also commit mistakes in between. That's okay. Chill. Look at this question. Give it a try. Give it a try, people. Give it a try. Standard electrode potentials are given. You are given with one electrode whose electrode potential is given as plus 0.15 volts, right? Similarly, copper tri-positive getting converted into copper, this is given as minus 0.74 volt. Okay? The cell potential will be. And it's mentioned that everything is in standard condition. So basically your cell potential, your E naught cell has to be calculated here, which will be simply E naught of cathode minus E naught of anode. So first of all, you need to understand among these two electrodes, which one will be cathode and which one will be anode. Which one will be cathode and which one will be anode? You need to check it first of all. Check it out quickly. Quickly, what do you think about this one? What do you think about this one? Who is this nonsense coming in between? Muiza. Muiza, I'm sorry you are getting blocked. You can go to some other channel. Quickly, guys. So first of all, check it out. +4 to +2, decrease in the oxidation state means reduction. So this is basically your SRP, right? +3 to 0, decrease in the oxidation state. This is also SRP. Now, if you look at these values, this SRP is more SRP means reduction. So this will behave like the cathode. This will behave like the anode, right? And already we are given with SRPs. So E naught of cathode, SRP of cathode is nothing but 0.15 minus SRP of anode is what? Minus 0.74, correct? Now what will be the value exactly? Value will be 0.89 volts. Is it clear? Simple and basic question. We discussed it in the last session as well. Yeah? In detail, we have discussed all these things. Okay, look at this particular question. It's again an easy question, guys. Hypothetical electrochemical cell is shown. EMF of the cell is 0.2 volts. So EMF is positive. EMF is positive. So cell reactions are spontaneous. That means it is absolutely correct. This is your anode, this is your cathode. At anode, oxidation will happen. At cathode, reduction will happen. So what will be the reactions? If you write the reaction at anode, A gives A positive. So the reaction has to be A. It will give A positive. And with that A positive, you will write one electron. This is your reaction at anode. Similarly, what will be the reaction at cathode? Reaction at cathode. B positive gives B. So B positive will be basically gaining one electron, will be getting converted into B. Electrons are balanced in both. So add them up. When you add them up, so A plus B positive gives A positive plus B. This is your net reaction, right? Now, which one is it? It is absolutely your option A. It is absolutely your option A. It's absolutely your option A. I hope this is clear. I hope this is clear. What do you think about this one? What do you think about this one? You're given with a cell. And if concentration of zinc dye positive as well as copper dye positive, both are doubled, what will happen to EMF? What will happen to EMF? My dear students, first of all, if you write the net cell reaction here, net cell reaction will be, I'm writing it directly, zinc plus copper dye positive gives zinc dye positive plus copper solid. This will be your net reaction, right? This is aqueous, and this is solid. If you write the reaction quotient for this will be concentration of zinc dye positive raised power 1 divided by concentration of Cu dye positive raised power 1. Okay? If you write the Nernst equation says that E cell is equal to E naught cell minus 0.0591 divided by N, then it's going to be log of QC, where QC is what? Concentration of zinc dye positive divided by concentration of Cu dye positive. This is your Nernst equation. Now, as per the question, if you double the concentration of this as well as this, if you make it 2 times, if you are making numerator 2 times, denominator 2 times, they'll get cancelled out. What will happen to E cell? Nothing. It remains the same. It remains the same. You got it? You're doubling the concentration of both. This is doubling, this is doubling. So 2 will get cancelled out. So nothing is going to happen to E cell. I hope I'm clear with this. I hope I'm clear with this. Look at this question carefully. Look at this question carefully. This is the salt bridge in between. On the left side, you have got hydrogen electrode whose partial pressure is H2. On the right hand side also, you have got hydrogen electrode. On both the sides, you've got same electrode. So which cell is it? Which cell is it? It is a concentration cell. It is a concentration cell. What do we have to calculate? We have to calculate EMF of the concentration cell. If you remember in your concentration cell, if you remember in concentration cell, your E naught cell is 0. Your E naught cell is 0. That's something which you should know. Now, we'll follow the same procedure. First of all, what should be the reaction at anode? At anode oxidation, H2 gives H positive. So when hydrogen electrode behaves like the anode, the reaction has to be H2, whose pressure is P1. It gives 2 times H positive aqueous. 2 times H positive aqueous plus how many electrons? 2 electrons. This is the reaction at anode. Similarly, reaction at cathode. Reaction at cathode will be how much? What will be the reaction at cathode? Reaction at cathode will be 2 times H positive aqueous. 2 times H positive aqueous plus 2 electrons. Gives what? Gives H2 gas. Whose pressure is what? Whose pressure is P2. Are the electrons balanced? Yes, the electrons are balanced. You can add them up. When you add them up, this term cancels. 2 gets cancelled. So your net reaction becomes H2, whose pressure is P1, gives H2, whose pressure is P2. This is our net reaction. If I ask you what is the N value here? N value here is 2, right? What is the QC expression? QC expression is nothing but P2 divided by P1. Are we given with P1, P2 values? Yes, we are given. P2 is 420. And P1 is what? P1 is 600. Can you solve this a bit? 42 divided by 60. How much it comes out to be? 67, right? 610. So 7 divided by 10. 7 divided by 10 we got as QC. Now, we'll be using the Nernst equation. Someone is saying, sir, how to find its aqueous or solid? If it is a solid, it will be mentioned as S. Whereas all the other ions which will be there in the net reaction, they have to be in aqueous form, all the other ions. Okay? Now, people, we have to calculate E cell. E cell has to be equal to E naught cell is 0 minus. Instead of 0.0591, we have to take 0.06 divided by N is 2 log of QC. QC is 7 by 10. QC is 7 by 10. So it is just a matter of calculation now. 0.06 divided by 2, that will be 0.03. This will be log of 7. Log of 7 as per the equation is 0.85. Log of 10 is 1, right? So it will be minus 0.03 multiplied by minus 0.15. Solve this, get the answer. That's it. That's something which you are supposed to calculate. I hope you can solve this sort of equation as well. Yes, is it clear? Is it clear, people? Say it quickly. Say it quickly. Okay, this thing is something which I want you guys to solve. I want you guys to solve this. Electrochemical cell is given. E naught of this is given. E naught of this is given. From this data, we can deduce the data which is given to us. What can we conclude here? What can we conclude here? My dear students, if you look at the cell, on the left side of the cell, what do we have? We keep the salt bridge. I mean, on the left side, we keep the anode. On the right side, we keep the cathode generally. So your M electrode is behaving like anode. It has to behave like anode. It has to behave like cathode. But, we have to deduce something from the data. As per the data, E naught of M gives M is equal to 0.44 volts. And E naught of X gives X negative. It is 0.33 volts. Correct? Check it out. Plus 1 to 0, decrease, reduction potential, SRP. 0 to minus 1, SRP. Which one has got more SRP? First one. The one which has got more SRP will undergo reduction, which happens at cathode. So basically, this should work like the cathode and this should work like the anode, right? But in the given cell, they have reversed it. But in reality, what has to be there? This has to work like anode, this has to work like cathode. So what has to be the actual cell representation for the cell to be spontaneous? This is the salt bridge. On left side, I have to write anode. This is anode. At anode, what happens? Oxidation takes place. See, this is 0 to minus 1, decrease. Decrease means reduction. But I have to write it in the oxidation format. So this I'll write as X negative. This I'll write as X. In the middle, this is salt bridge. On the right side, cathode. At cathode, what happens? Reduction takes place. Reduction means M positive gives M, plus 1 to 0. Perfect. This is the actual cell representation as per the data which is given to us. Now, as per this cell representation, As per this cell representation, what has to be the cell reaction? At anode, oxidation will happen. At anode, oxidation will happen, right? X negative, from -1 to 0, -1 to 0, increase. Increase means oxidation. So X negative will lose 1 electron and will get converted into X. This is the reaction at anode. Similarly, reaction at cathode, M plus gives M. So reaction has to be M plus will accept 1 electron, will get converted into M, right? Electrons are balanced. Your net reaction has to be X negative plus M positive. It gives X plus M, right? This has to be the net reaction, which will be spontaneous. Okay? Now, which is the correct answer? Is there any option like this? M positive plus X negative gives M plus X. It is option 2. Am I clear with this? Am I clear with this, people? Am I clear with this? Yes? Perfect. One simple and basic question. You have to let me know the value of reaction quotient. In order to get the reaction quotient, we have to write the net cell first of all. Net cell reaction first of all. At anode, zinc is getting converted into zinc dipositive. So zinc solid is losing 2 electrons and getting converted into zinc dipositive. Ag positive will be gaining 1 electron and getting converted into Ag solid. Now, if I ask you, are the electrons balanced? No, the electrons are not balanced. So what am I supposed to do? What am I supposed to do? What am I supposed to do? I'm supposed to balance the electrons. So multiplying this reaction by number 2. So this has to be 2 times, this has to be 2 times, this has to be 2 times. Now you can add these reactions. This 2 electron cancel, right? I'll be getting zinc solid plus 2 times Ag positive aqueous. It gives zinc dipositive aqueous plus 2 times Ag solid. This is my net cell reaction. If this is my net cell reaction, now I can write the reaction quotient expression, right? Start with here, from here. It is concentration of zinc dipositive raised by stoichiometric coefficient 1. This is solid, nothing to do with this, divided by solid, nothing to do with this. It's going to be concentration of Ag positive raised to the power 2. Stoichiometric coefficient is 2. Now put the values and get the answer. That's it. What is the concentration of zinc dipositive? 10 raised by -2 molar. 0.01 divided by. Here it is 1.25 molar raised power 2. Right? Perfect. Calculation. And done. Yes? Am I clear? Am I clear? So after calculating, it will be option 4. That's great, Ansh. Congratulations. Congratulations. The blessings are always along. I hope all these sort of questions you can easily solve. Okay. One more similar question to calculate E naught cell. I am not going to solve it. You are going to solve it. Let me know the answer quickly. Let me know the answer quickly. Let me know the answer quickly. I am not solving this question because I've solved many questions like this. E naught cell you have to calculate. Standard EMF, E naught cell. E naught cathode minus E naught anode. SRP of cathode minus SRP of anode. Right? SRP of cathode, that means SRP of copper, 0.34 minus SRP of magnesium, minus 2.37. Right? So add them up. It will be 2.71. Right? Sign you can check. So what is the answer of it quickly? Quickly guys, what is the answer of this question? Majority is saying C, so it will be C only. Great. All right, look at this particular one. We are given with a cell reaction. EMF is given. right? Okay, standard EMF is given. The standard EMF is given. The EMF of the cell reaction when 0.1 molar Cu dye positive and 0.1 molar zinc dye positive solutions are used. How do you solve this one? How do you solve this one? It is a simpler one. The reaction is already given. So first of all, get the reaction quotient. How? Concentration of zinc dye positive raised power 1 divided by concentration of copper dye positive raised power 1. Well, the concentrations are given. This is 0.1, that means 10 raised power minus 1, right? And copper dye positive is also 0.1. So QC is 1. QC is 1. If QC is 1, have a look, guys. E cell is equal to what? E cell is equal to E naught cell minus 0.0591 divided by N log of QC. Here QC is 1. If QC is 1, log of 1 is 0. This entire term is becoming 0. So your E cell and E naught cell are same. And as per the question, E naught cell is given 1.1 volts. So your E cell will be also 1.1 volts. Right? Clear with this? Clear with this? Absolutely. Option A. Wonderful, guys. Moving ahead. Moving ahead. Can you give this question a try? For the cell whose E naught is given, by which of the following activity E cell will increase? By which of the following activity E cell will increase? Slowly, I'll increase the level. These are easy questions which I'm giving you. Just wait for some time. Wait for some time. Right? Wait for some time. What do you think about this one? How E cell will increase? How E cell will increase? First of all, if you write the net reaction, what will be the net reaction? See, at your anode, nickel will be getting converted into Ni dye positive plus 2 electrons, right? At your cathode, copper dye positive will be gaining 2 electrons, will be getting converted into copper solid. Perfect. Your net reaction will be nickel solid plus copper dye positive aqueous. It gives what? It gives nickel dye positive aqueous plus copper solid. This is your net reaction. If this is the net reaction, N values 2, perfect, N values 2. Now, QC. QC has to be concentration of Ni dye positive divided by concentration of Cu dye positive. When you calculate QC, this is your QC basically. Now, if you write the expression E cell is equal to E naught cell minus 0.0591 divided by N log of QC. What is QC? That is concentration of nickel dye positive divided by concentration of Cu dye positive. Now, you have to see how E cell will increase. 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 E cell will only increase if this term decreases. This term. When this term decreases, then only the difference of these two. Then only the difference of these two will increase. So this term has to decrease. Right? This term has to decrease. Now, when this particular term will decrease, it will decrease only if this numerator decreases, denominator increases. Numerator decreases, denominator increases. Numerator decreases, denominator increases. What is numerator? Nickel dye positive concentration has to decrease. Nickel dye positive concentration has to decrease. Then only E cell will increase. Perfect? Perfect? Perfect, people? Okay. We are given with a reaction. Sir, I saw a picture on Instagram. Is that your sister? No, that's my fiance, the one who I'm going to marry. Okay? Okay? Cool? Do you want to know something else? Do you want to know something else? Again, the similar question. Again. Again, the similar question. Again, the similar question. Okay, how do we solve this particular question, people? I believe if you look at this particular question, here you have got the equilibrium sign. Here you have got the equilibrium sign. And at the same time, your Kc is also given. Kc is also given. Yeah? Kc is also given. So what it means exactly? It means the cell is at equilibrium. When the cell is at equilibrium, you know it. E cell is equal to 0. When the cell is at equilibrium, E cell is equal to 0. What do we have to calculate? We have to calculate E naught cell, right? At equilibrium, if you remember, how do we write the Nernst equation? E naught cell is equal to 0.0591 divided by n log of Kc. Log of Kc, correct? What do we have to calculate? E naught cell. So E naught cell has to be equal to 0.0591. Can you let me know the n value for this reaction? Just asking. Can you let me know the n value for this reaction? This is 0 to plus 2. Done. N is 2. N is 2. N is 2. Log of. What is Kc? Kc is 10 raised power 12. M raised power n is n log m. So it is 0.0591 divided by 2. Then you have got 12. Log of 10 is 1. Solve this. Get the answer in volts. Done and dusted. Done and dusted. Right? Done and dusted, people. Let me show you some good questions. Then we'll go back to these easy questions. Okay? Some good questions we are going to do now. Have you seen this sort of a question ever? Look at it carefully. A solution containing H positives and D positives. D positive, deuterium, D positive, is in equilibrium with the mixture of H2 and D2 gases at 25 degrees centigrade. If the partial pressure of both the gases are 1 atm, find the ratio of concentration of D positive and H positive concentration. My dear students, the question says that you have got two electrodes. One is your hydrogen electrode. One is your deuterium electrode. Deuterium electrode, right? You know, SRP as well as SOP of hydrogen electrode, that is 0. That is 0. Look at this one. D positive to D2. So plus 1 to 0. Decrease in the oxidation state. Reduction. So this SRP. So SRP of D2 is given. Minus 0.003 volts, right? Look, this is 0. This is minus something. So which has got more SRP? This has got more SRP. More SRP means reduction. Reduction takes place at cathode. So when you connect these two electrodes, this will be working like the cathode and this will be working like the anode. Right? Perfect. Right, people? So I got to know that this electrode is going to behave like the cathode and this electrode is going to behave like the anode. So let me first of all represent the cell so that it becomes clear to you. Let me first of all represent the cell. My dear students, this is the salt bridge. On the left side of the salt bridge, I'll be writing anode. Which one is my anode? It is a deuterium electrode, which is my anode. So I'll write D2 gas. D2 gas gives D positive. D positive aqueous. This is my anode. Right? You can check it out. 0 to plus 1. Increase. Oxidation. Anode. Right? Now, on the right side, we'll be writing the cathode. Right? Cathode is your hydrogen electrode. How do I write it? H positive aqueous gives what? It gives H2 gas. It gives H2 gas. This is my cell representation first of all. This is my cell representation first of all. Okay? I've represented the cell. Since I've represented the cell, my dear students, can I write the reaction taking place at anode and cathode? At anode, I'll say D2 gas gives 2 times D positive aqueous plus 2 electrons. Similarly, at cathode, what is going to happen? At cathode, reduction is going to happen. 2 times H positive aqueous will be gaining 2 electrons and will be getting converted into H2 gas. Electrons are balanced. I can write the net reaction. Net reaction will be D2 gas plus 2 times H positive aqueous. It gives 2 times D positive aqueous plus H2 gas. Perfect. This is my net reaction. This is my net reaction. This is my net reaction. Okay. My dear students, if this is the net reaction, N value is 2. Okay. N value is 2. Get the QC expression. How do you get the QC expression? It's going to be, see, as per the question, it's mentioned that take the partial pressure of both the gases as 1. Partial pressure of both the gases is taken as 1. Perfect. Partial pressure of both the gases has been taken as 1. So QC, it is concentration of D positive raised power 2 divided by concentration of H positive raised power 2. So I'll take that 2 over here as common. Perfect. Right? Now people, let's use the Nernst equation. What do we have to calculate actually? Okay. Just a second. Partial pressure is given. This is given. What do we have to calculate? Find the, a solution containing H positive, this. Okay, in equilibrium of the mixture at 25 degrees centigrade, if the partial pressure of this and this is this, given that E naught is this, find the ratio of D positive divided by concentration of H positive. Concentration of H positive. Okay. How do you solve it, guys, now? How do you solve it? How do you solve it? In the question, one hint is given. In the question, one hint is given. In the question, one hint is given. Done? So should I be using the equilibrium condition here? Let me use the equilibrium condition here. So I'll say E naught cell has to be equal to 0.0591 divided by N log of, instead of QC, you can call it KC. So it's going to be concentration of D positive divided by concentration of H positive whole raised power 2. Whole raised power 2. Perfect. E naught cell. E naught cell is your E naught of cathode minus E naught of anode. Right? SRP of E naught cell. E naught cathode. This is your cathode. Where is the cathode? 0. Right? E naught cathode is 0. Minus E naught anode. SRP of anode is this. So 0 minus this. It will come out to be 0.003. Lot of calculation, guys, here. 0.0591. N value is 2. Log of M raised power N log 2. So 2 comes here. It's going to be log of concentration of D positive divided by concentration of H positive. So 2 gets cancelled out. Right? 2 gets cancelled out. Perfect. So you got 0.003 divided by 0.0591 is equal to log of concentration of D positive divided by concentration of H positive. Can you let me know what this value comes out to be exactly? I want the exact value. I want the exact value, guys. Can you let me know what is the exact value which is coming out from here? Exact value I would need. How much is it? I need the exact value. Quickly, let me know in the chats. I need the exact value, guys. Quick. Is it 0.05? So this is coming out to be 0.05. This is coming out to be 0.05, right? 0.05. Now I'll be asking you a question here. Log of D positive divided by H positive is coming out to be 0.05, right? See, log of 1 is 0. Log of 2 has to be 0.3. Right? Log of 2 has to be 0.3. So, the answer of D positive divided by H positive has to be between 1 and 2. Correct? Log 1 is 0. Log 2 is 0.3. Perfect. It has to be between 1 and 2, but there are like two options between 1 and 2. There are two options. So either it's going to be this one or it's going to be this one, right? Or it's going to be this one. But guys, what I believe, in the question, you will be given with the value of NT log of 0.05. You'll be given with the value of NT log of 0.05. Okay? Got it? Am I clear with this? See, this is D positive divided by H positive. It will be NT log of 0.05. It will be NT log of 0.05. In the question, it will be mentioned how much NT log of 0.05 will be. Right? Or if you can take the approximation, to approximation, you can neglect these two options, this one and this one. See, log of 1 is 0, log of 2 is 0.3, right? Log of 1 is 0, log of 2 is 0.3. And this value, it is coming between. It is coming between, right? So D positive divided by H positive. Either, I mean, it's going to be between 1 and 2. Between 1 and 2. Closer to 1. Closer to 1. Closer to 1. So what has to be the answer of this particular question? Closer to 1. Closer to 1 is 1.12. If this sort of a question comes, it will take a lot of time, right? I get that completely. I get that completely. Just a second. This question, let's give this question a try. Again, one simple question this is. You are given with a cell reaction from there only, right? The measured voltage, E cell is given. E cell is given as 1.5. What do we have to calculate? E naught cell. What do we have to calculate? E naught cell. Can you do it? Can you do this question? Can you do this question? It is a similar question, guys. What you are supposed to do? First of all, you'll get the N value. You'll get the N value. See, chromium 0, this is plus 3. 0 to plus 3, right? 0 to plus 3. Perfect. What will be the N value? N value will be 3. N value will be 3. N value will be 3 when you calculate it. You know how do we do it. If N is 3, you can write QC expression, which will be concentration of Cr tri positive, which is 0.3, right? Divided by concentration of Ag positive ka cube, right? This is 0.1 means 10 raised power minus 1 raised power 3. This is QC. Now you have to use a Nernst equation. E cell is given. E cell is equal to E naught cell minus 0.0591 divided by N log of QC, right? One equation, one unknown, you can calculate, right? Oh, I have already given the answer. I mean, you can solve this question because these sort of questions we have done it. These sort of questions we are done with. Okay? Just a second. Okay. If I ask you one simple question over here. The nature of curve of E naught cell versus log Kc. Kc, equilibrium constant. That means cell is at equilibrium, E cell is 0. Cell is at equilibrium, E cell is 0. Therefore, you will be using this expression. E naught cell is equal to 0.0591 divided by N log of Kc. What do we have to draw? We have to draw the curve between E naught cell versus log Kc. E naught cell is you'll be plotting along y-axis. Log Kc, plot along x-axis. This becomes your slope m. Y is equal to mx. Y is equal to mx means straight line. Right? Y is equal to mx means straight line. Y is equal to mx means straight line. Okay, this question, no need to solve. Just see the question and tell me the answer. In the Nernst equation, if Q will be equal to equilibrium constant, if Q is equal to K, at that time, if Q is equal to K, at that time, what happens? Q is equal to K means equilibrium condition. If it is equilibrium condition, then at equilibrium, E cell is 0. E cell is 0. Why you are writing 1? E will be equal to E naught when QC is 1. If QC is 1, log of QC, log of 1 is 0. Then E is equal to E naught. But here the question is different. The question is different. So you have to look at the options. Do not rush. Do not rush. Do not rush at all. Just a second. Let's solve certain questions. Then I'll come to these questions again. Look at this particular question. The oxidation potential of the hydrogen electrode. The oxidation potential of the hydrogen electrode at pH equal to 10. Oxidation potential of the hydrogen electrode at pH is equal to 10. And partial pressure of H2 is equal to 1 atm will be. So basically you have got the hydrogen electrode like this. Let's say this is the solution containing H positives whose pH is given to me as 10. pH is given to me as 10. And this is your hydrogen electrode, right? You know how do we make this hydrogen electrode? Its partial pressure is 1 atm. Correct? This is your hydrogen electrode. I have to calculate its oxidation potential. If I need to calculate its oxidation potential, I'll make sure this hydrogen electrode behaves like the anode. And when hydrogen electrode behaves like the anode, what reaction takes place? Oxidation reaction. And the reaction will be simply H2 gas gives 2 times H positive aqueous plus how many electrons? 2 electrons. If I ask you how many moles of electrons are exchanged here, 2. N is equal to 2. If I ask you what is the reaction quotient, QC, QC will be concentration of H positive raised power 2 divided by partial pressure of H2. Now you must be thinking, how do we calculate the concentration of H positive, right? Since pH is given as 10, when pH is given as 10, from pH you can calculate H positive concentration. H positive concentration is 10 raised power minus pH. Do remember this, right? Perfect. So H positive concentration here will be 10 raised power minus 10 molar. This is your H positive concentration. If you got the H positive concentration 10 raised power minus 10, 10 raised power minus 10. So this is 10 raised power minus 10 raised power 2. So it becomes 10 raised power minus 20 divided by partial pressure of H2 is how much? That's 1. So this is your QC. If this is your QC, what am I supposed to calculate? Oxidation potential. So I'll write the Nernst equation in the form of oxidation potential. I hope you remember. I'll write EOX is equal to E naught OX minus 0.0591 divided by N log of QC. Correct? Now, since we are given with a hydrogen electrode whose SOP is 0, so this is 0. N value already we know that's 2. QC value is equal to 10 raised power minus 20, right? So you can calculate it. EOX is equal to minus 0.0591, N value is 2, log of QC, QC is 10 raised power minus 20. So I'll say oxidation potential is equal to minus 0.0591 divided by 2 log of M raised power N, which is N log 10 is 1. 2, 1, 2, 10. So this is 0.591 volts. Is there any option like that? 0.591 volts. So option 3 is the one which is correct. Right? Perfect. Similar sort of approach which I gave you in the last session. Usage of Nernst equation. Usage of Nernst equation. Usage of Nernst equation. Usage of Nernst equation. Just a second. Can you solve this one? Can you solve this one? Standard electrode potentials. Li positive to lithium plus 1 to 0 decrease in the oxidation state, reduction. So its SRP is minus 3.03 volts, right? Similarly, Ba di positive gives barium. It's again SRP. How much? Minus 2.74 volts. Then you have got Na positive to sodium, minus 2.71 volts. Then you have got Mg di positive, again SRP, so Mg. It is equal to how much? It is equal to minus 2.37 volts. Perfect. If you look here, plus 1 to 0, reduction. So Li positive is undergoing reduction here. This is undergoing reduction here. This is undergoing reduction here. This is undergoing reduction here. And which potentials these are? These are your SRPs. These are your SRPs. I have to check which of the following is the strongest oxidizing agent. Oxidizing agent undergoes reduction. Oxidizing agent undergoes reduction. Right? Perfect. The one which undergoes reduction easily is the better oxidizing agent. Is the better oxidizing agent. And which one undergoes reduction easily? The one which has got more SRP. Now check these values. Which of the following has got which value is maximum among all? Which value is maximum among all? This is the maximum value, right? Perfect. This is the maximum value among all. When you compare, this is the maximum value among all. Perfect. If this is the maximum value, maximum SRP means maximum tendency to undergo reduction. So Mg dye positive will undergo reduction easily. If Mg dye positive undergoes reduction easily, it will be the better oxidizing agent. So it has to be option D. It has to be option D. Right? It has to be option D. Even this question you should be able to solve easily. Even this question you should be able to solve easily. Standard electrode potentials. They're just giving you standard electrode potentials. They are not mentioning whether it is SRP or SOP. Whenever it is not mentioned that whether it is SOP or SRP, you'll be always considering that as SRP. They are in general mentioning standard electrode potential. So consider it as standard reduction potential. Remember this. Okay. So standard reduction potential of X is given as minus 1.2. Standard reduction potential of Y is given as plus 0.5. Standard reduction potential of Z is given as minus 3.0. Perfect. These are SRPs. We have to check the reducing power. We have to check reducing power, right? We have to check the reducing power. Now, you know, a reducing agent, the one which is the better reducing agent, that has the more reducing power. Now, reducing agent undergoes oxidation. So the one which undergoes oxidation easily, better reducing agent, more reducing power. Now, which one undergoes oxidation easily? The one which has got more SOP. But these are SRPs. What do I need? I need SOPs. I need SOPs. So reverse the sign. Plus 1.2, minus 0.5, plus 3 volts. Right? Now, which one has got maximum SOP? Z. Z has got maximum SOP, maximum tendency to undergo oxidation, better reducing agent, more reducing power. So Z has maximum reducing power. Followed by X. Followed by Y. Is there any option like that? Z, X, Y. Am I clear? The concept I've given you in the last session, if you remember. Okay? So, this question is again easy. Tell me about this one. Here I want to see how much do you remember things. Here I want to see how much do you remember. You're given with standard reduction potentials, right? If you look in the first reaction, zinc dye positive is undergoing reduction, right? These are SRPs. These are SRPs. So if I mention it like this, zinc dye positive, when it undergoes reduction, right? Its SRP is minus 0.76 volt. Similarly, a chromium tri-positive, when it undergoes reduction into chromium, its SRP is minus 0.74 volts. Over here, H positive, when it gets converted into H2, it is 0 volt. It is 0. Then at the end, we have got when Fe tri-positive undergoes reduction, right, into Fe di-positive, its SRP is how much? 0.77 volt. What do I have to check? Strongest reducing agent. Strongest reducing agent. Reducing agent undergoes oxidation. The one which undergoes oxidation easily will be the better reducing agent, right? Now, which one undergoes oxidation easily? The one which has got more SOP will undergo oxidation easily. Now, how do you check? SOPs you have to compare. But what do I have? I have these SRP values. I'll convert them into SOP values. When I convert them into SOP, I'll write zinc gives zinc dye positive is equal to plus 0.76, right? Chromium gives chromium tri-positive is equal to plus 0.74, right? H2 gives H positive is equal to 0. Fe di-positive gives Fe tri-positive. This is equal to minus 0.77. If you look at these values, now here zinc is undergoing oxidation, chromium is undergoing oxidation, hydrogen undergoing oxidation, Fe di-positive undergoing oxidation. Which one do you see has got maximum oxidation potential? This is the maximum oxidation potential value, right? So maximum SOP, maximum tendency to undergo oxidation, better reducing agent. So I'll say it is the zinc which is going to be, it is the zinc which is going to be the better reducing agent. Clear? Clear, people? I'm pretty much sure this is again clear to everyone. One more question of the similar format. These are all asked questions. You need to give it a try and tell me the answer. Quick. You need to give it a try. You will give it a try. I'm not solving this question because I've solved many questions like this now. You have to give it a try. Quick. Reducing power means better reducing agent. Means the one which will be undergoing oxidation easily. So you have to check SOPs. But these are SRPs. These are SRPs. These are SRPs. Convert them into SOPs. So which one will be having maximum SOP? It will be calcium. When you reverse the sign, it will be calcium. Calcium will be having maximum SOP. Right? I'm not going to solve this. You will solve this, yeah? So majority is coming out with option B. So I believe you are right. Hello? It's option B. It's option B. Okay, do not get confused in this question, guys. Do not get confused in this question. See, I have told you E0 cell. E0 cell is equal to E0 cathode, which is SRP of cathode minus SRP of anode, right? But at the same time in the yesterday's session, I have told you can interchange the results as well. You can write it like this. E0 cell is equal to, instead of SRP of cathode, you can write minus times SOP of cathode. Correct? Perfect. I interchange this. This I'm keeping same. This I'm keeping same. It won't change, right? This can be one more result. This can be one more result. This is one of the results. This can be one more result. The choice is all yours. What kind of interchange you want to do? Minus SOP of cathode I'm keeping as such. Minus times. Instead of SRP of anode, I'm writing minus times. I'm writing minus times. Minus times SOP of anode. That minus becomes plus. So it can be oxidation potential of anode minus oxidation potential of cathode. This can be one more result. This can be one more result. Right? This can be one more result. Perfect. Similarly, guys, you can do the rest of the things. You can interchange and get the formulas. Okay? Okay? So it is SOP of anode minus SOP of cathode. OP of anode minus OP of cathode. OP of anode minus OP of cathode. Right? OP of anode minus OP of cathode. This is correct. Right? SRP of cathode minus SRP of anode. Which one is the another one which is correct? I mean, you can solve this. You can interchange them, right? You can interchange them and get the desired ones. Get the desired ones. Get the desired ones. If you look at this particular equation carefully, you can write the first one as such. SRP of cathode. SRP of cathode. Instead of SRP of anode, you can write minus times. You can write minus times SOP of anode. So minus becomes plus. SOP of anode. Is there any option like that as well? SRP of cathode. SRP of cathode. SRP of cathode plus SOP of anode. Just a second. SOP of anode. OP of anode is here. OP of anode plus RP of cathode. OP of anode plus RP of cathode. So it has to be option 2 as well. So 2 as well as 4. 2 as well as 4. Yes. Done? Perfect. Perfect, guys. So it is 2 as well as 4. I need to turn the lights off. 2 as well as 4. These sort of questions are, guys, tricky questions. So you have to properly look into them. Then only you can solve them. Then only you can solve them. Can you solve this question? Can you solve this particular question? Calculate the oxidation potential of the following half cell. I'm giving you the half cell. See exactly what this half cell means. It means that you have taken a container. In this particular container, you have kept FeSO4, right? And this FeSO4 would have undergone dissociation as Fe di positive plus SO4 di negative. Perfect. Initially, what is the concentration of FeSO4 which you are taking? 0.1 molar. So initially this will be 0, this will be 0. Now, this FeSO4, assume that it undergoes 100% dissociation. So I'll be left with nothing here. 1 mole gives 1 mole, 0.1 gives 0.1. 1 mole gives 1 mole, 0.1 gives 0.1. So basically in this container, concentration of Fe di positives and concentration of SO4 di negatives, both are 0.1 mole. You know it. You got it, right? Now, what do I have to do basically? I have to calculate the oxidation potential of this half cell, right? This is your iron electrode. This is your iron rod. Perfect. I have to calculate oxidation potential of this electrode over here. Yeah? Oxidation potential. So first of all, in order to calculate the oxidation potential of this electrode, I'll make sure that the electrode behaves like anode. When the electrode behaves like anode, oxidation will happen, right? Oxidation means loss of electrons. See, this is 0 here, this is +2. 0 to +2, increase. So basically, iron solid will be getting converted into Fe di positive aqueous, and with that, you'll be writing 2 electrons. So N value is first of all 2. Write the QC expression. QC is nothing but concentration of Fe di positive raised power 1. Concentration of Fe di positive, we have already calculated. That's 10 raised power -1. Okay. Now, I'll write Nernst equation. Oxidation potential is equal to standard oxidation potential minus 0.0591 divided by N. Then it's going to be log of QC. Perfect. So, EOX is equal to standard oxidation potential. Is this SOP or SRP? +2 to 0, decrease. Decrease means reduction. So, this is SRP. Change the sign, make it SOP. Plus 0.44. Plus 0.44. Minus 0.0591. N value is how much? N value is 2. Log of QC is 10 raised power -1. So 0.44 minus 0.0591 divided by 2. Log of m raised power n is n log m. Right? All this, get the answer in volts. Okay, and when you solve this at the end, you'll be getting the exact value as 0.47. Okay, 0.47. 0.47. All right, look at this particular question. Look at this particular question. Look at this particular question. You should be able to solve this one as well. Calculate the EMF of the cell. E naught cell is given and the cell is also given. Try to understand, guys. Try to understand. There's the salt bridge on the left side, anode, on the right side, cathode. So first of all, write the reaction at anode. Reaction at anode. M gives M di positive. So I'll say M solid will be giving M di positive aqueous, and with that, you'll be having 2 electrons. Right? With that, you'll be having 2 electrons. And this M di positive, its concentration is given as 0.01 molar. Correct? Reaction at cathode. M di positive gives M. So M di positive aqueous, whose concentration is this 10 raised power -4, right? This 10 raised power -4 molar. Perfect. It will be gaining 2 electrons. It will be getting converted into M solid. Electrons are already balanced. Electrons are already balanced. Do one thing, add them up. Add these 2 reactions. So 2 electrons cancel, M cancel. This and this, they won't get cancelled because there's a concentration difference. There's a concentration difference. So my net reaction is going to be M di positive, whose concentration is 10 raised power -4 molar. It gives what? It gives M di positive, whose concentration is 10 raised power -2 molar. Right? 0.01. So QC you can calculate from here. It's going to be 10 raised power -2 divided by 10 raised power -4. The value will be nothing but 10 raised power 2. QC you got. QC you got. Now, Nernst equation you'll be using. Nernst equation you'll be using. Right? Nernst equation you'll be using. You'll simply write E cell is equal to E naught cell is given as 4 minus 0.0591 divided by N value is 2 log of QC. QC is 10 raised power 2. Matter of calculation, 0.0591 divided by 2. This is going to be 2 log 10. Log 10 is 1, 2 to cancel. So 4 minus 0.0591, right? This is going to be the answer of the question, which will be how much? 3 point something, right? 3 point something it will be. Am I clear? Or did I take minus plus somewhere? Okay. I hope this is clear. Look at this particular question. Look at this particular question. Calculate the oxidation potential of this half cell. Oxidation potential of this half cell. Guys, if you look at the questions, let's see first of all what the question is. Cl2 HCl, okay. See what the question says. I have to calculate the oxidation potential, so I have to make sure that this electrode behaves like the anode. At anode, oxidation takes place. You know it already, right? Perfect. Now, if you look at the oxidation state here, it's 0. Chlorine here is -1. 0 to -1. Decrease. Decrease means reduction. Decrease means reduction. But what do you have to calculate? Oxidation potential. What do you have to calculate? Oxidation potential. Mohammed, I know that. I know that. It was supposed to be, E0 cell was supposed to be 0 in the last question, but it was given, so I took it. Okay? It was a hypothetical one. All right, so this is 0 to -1. First thing, I have to calculate oxidation potential, so I have to make sure that electrode behaves like the anode. At anode, oxidation should take place, right? Oxidation should take place. But during oxidation, do you think Cl2 has to get converted into Cl negative or Cl negative has to get converted into Cl2? If it is 0 to -1, decrease, reduction, no. I have to go in the reverse format. It is basically Cl negative has to get converted into Cl2. So the reaction has to be twice Cl negative aqueous, right? It will get converted into Cl2 gas plus 2 electrons. This is the reaction. This is the reaction. This is the reaction. Correct? This is the reaction. If this is the reaction, get the QC value. Partial pressure of Cl2. Partial pressure of Cl2 is 10 raised power 1. Concentration of Cl negative, 10 raised power -1 raised power 2. Perfect. So 10 divided by 10 raised power -2, the value comes out to be 10 raised power the value comes out to be 10 raised power 3. So this is QC. I hope this is clear. This is QC. This is QC. If this is QC, now calculate the oxidation potential. EOX is equal to E0OX minus 0.0591 divided by N, and it's log of QC, correct? So EOX has to be equal to E0OX, standard oxidation potential. -1 to 0, -1 to 0, -1 to 0, increase, oxidation. So this SOP, I'll take the exact value, -1.36, minus 0.0591. What is the N value? N value is 2, log of QC. QC is 10 raised power 3. Log of M raised power N, N log M, right? So it's going to be 3 log 10. 3 log 10 means it's going to be just 3. Log 10 is 1. Matter of calculation now. You'll be getting the oxidation potential in volts. I hope this sort of a question, again, you can solve. And after doing the calculation part, you'll be getting the answer exactly as -1.45 volts. Okay? -1.45 volts. Now, let's try to do some other questions. Look at the question. This might be a bit lengthy, but let's see what the question is. Again, we are given with a complete cell, right? On the left side of the solder bridge, we have got anode. On the right side, we have got cathode. Each cell is given, okay? And concentration of M di positive divided by concentration of M plus 4 is given as 10 raised power x. E0 values are given. E0 values are given. The value of x is. The value of x is. This x value we have to calculate. This x value we have to calculate. This x value we have to calculate. Okay? How do we solve this particular question? First of all, I'll be writing reaction at anode. At anode, oxidation will take place. So H2 gas will be getting converted into 2 times H positive aqueous plus 2 electrons. This is the reaction at anode. Now reaction at cathode. M plus 4, M plus 2. So M plus 4 aqueous will be gaining 2 electrons and will be getting converted into M di positive aqueous. Right? M di positive aqueous. Electrons are balanced, so add them up. So this and this gets cancelled, right? This and this gets cancelled. So my net reaction is going to be H2 gas plus M plus 4 aqueous. It gives 2 times H positive aqueous plus what? Plus M di positive aqueous. This is my net reaction. If this is the net reaction, how many moles of electrons got exchanged? 2. So N value is equal to 2. Guys, the process everywhere is same, right? right? Now, if I get the QC expression, QC is concentration of H positive ka square. H positive concentration is 1, so 1 ka square is 1 only. So I'll just write M di positive concentration divided by H2 gas pressure, 1 bar, leave it, M plus 4, right? Raised per what? M plus 4 raised per 1. If you look carefully, M plus 2 divided by M plus 4, M plus 2 divided by M plus 4, it's given as 10 raised per x. So this value is given as 10 raised per x. This value is given as 10 raised per x, right? Now, my dear students, QC is equal to 10 raised per x. Now, what do we do after this? Calculate the E naught cell. If you calculate E naught cell, which is basically your E naught of cathode minus E naught of anode. SRP of cathode. What is this value? Plus 4 to plus 2, decrease. Decrease means reduction. So this SRP, right? So 0.15 minus SRP of anode. Anode is hydrogen electrode, its SRP is 0. So 0.15 volts. Now, if I use the Nernst equation, E cell is 0.092. E cell is equal to E naught cell 0.15 minus 0.0591 divided by N. N is 2. Log of QC. QC is 10 raised per x. Right? Now, calculation has to be done. Right? Now, calculation has to be done. So, you have got one equation, one unknown. So, you just have to get the x value. Can you do it after this? Because I don't want to do any calculation here. Can you do after this? So finally, you are getting this kind of the equation, which is 0.059 is equal to 0.059 divided by 2, then log of 10 raised per x. Correct? Right? So this term gets cancelled. So 2 is equal to log of 10 raised per x. Perfect. So log of 10 raised per x is 2. What does that tell you? X is equal to, what does that tell you? When is this equation correct? What has to be the value of x such that LHS RHS becomes equal? Value of x has to be 2. Then only log of m raised per n. Then only LHS RHS will be equal. I hope you got to know the process. Can you solve this one? Standard Gibbs free energy you have to calculate. Delta G naught. What is delta G naught? Minus NF E naught. Right? Is E naught given? Yes, E naught is given. So this is simple. This is basic. N value. Calculate the number of electrons, number of moles of electron, which will come out to be 2. Faraday's constant 96500 coulombs. E naught is given as 2 volts. But we have to get the delta G, I believe, in kilojoules, right? Since I have taken everything as per SI system. So delta G will come as per SI system. And that is joules. But I want it in kilojoules. So I'll be dividing with 1000. Then only it will be coming in kilojoules, right? So this is the equation. Delta G naught you can calculate from here. I hope you're getting what I'm saying, right? Why I divide with 1000? Because I'm supposed to get the answer in kilojoules, not in joules. What should be the answer of this question? This is again the asked question. If E naught cell for the given reaction is negative, okay, E naught cell is negative. First thing, it's given. E naught cell is negative. If E naught cell is negative, then what about your delta G naught? Delta G naught will be minus NF E naught cell. If E naught cell is negative, that negative and this negative makes it positive. So delta G naught is positive. First of all, the answer is either this or this. Delta G naught is positive. Now, delta G naught as per the equation is equal to minus RT ln of KEQ. Now, for delta G naught, to be positive, for delta G naught to be positive, this term has to be negative, then because then only negative and negative makes it positive. Now, when is this particular term going to be negative? When is the ln of KEQ going to be negative? It is going to be negative if this term KEQ will be less than 1. If KEQ will be less than 1, because ln of X will be negative when X is less than 1, right? Done? Perfect. Solved. Guys, here is one more question which I think I have not showed you in the yesterday's session. Which I think I have not showed you in the yesterday's session. Have a look what the question is all about. Have a look. As per this question, copper di positive plus 1 electron gives copper positive. Its E value is given, which I am calling as E1. It is given as 0.15, right? The second reaction, that is copper positive plus 1 electron, gives copper solid. Its E value is also given to us as 0.54, right? What do we need to calculate? We need to calculate E naught of copper di positive gives copper. So if I write reaction for this, reaction has to be what? Reaction has to be copper di positive plus 2 electrons gives copper solid. So basically we have to calculate E value for this particular reaction. We have to calculate E value for this particular reaction. Now, how exactly you are going to solve this? First thing, how many moles of electrons are exchanged in the first reaction? 1, right? So N1 value I'm calling as 1. N1 is equal to 1. What about N2? N2 is 1. What about N3? N3 is 2. Perfect. The reaction whose E value is to be calculated, we need to make that reaction. So how do I make this particular reaction from the given ones? My dear students, it's pretty much simple, I believe. This is your equation 1, this is your equation 2. How do I get the third equation? If I add first and second, so copper positive cancel, 1 electron makes it 2 electron, copper di positive and copper. So third reaction I'm getting when I'm adding first and second. But no doubt, you're adding first and second and you're making the third reaction. If you think you'll do something like this, E3 is equal to E1 plus E2, whatever answer you'll be getting, that will be wrong. Because this E over here, this is something which I'll be teaching you in thermodynamics. It's an intensive property. And intensive properties cannot be added or subtracted directly. So, you will be solving the question in terms of extensive property. Your Gibbs free energy is the extensive property. For example, Gibbs free energy of the first reaction is delta G1, this is delta G2, this is delta G3. Right? So over here, instead of E3 is equal to E1 plus E2, what you'll write? For the third reaction, you'll use its delta G. Right? You'll solve the equation in terms of delta G. Right? Now guys, bit of calculation. Delta G3 will be equal to minus N3FE3 is equal. Delta G1 is equal to minus N1FE1. Delta G2 is equal to minus N2FE2. Right? F everywhere cancelled. So E3 at the end will come out to be N1E1 plus N2E2 divided by what? Divided by N3. Do we know the value of N1? Yes. Do we know the value of N2? Yes. Do you know the value of N3? Yes. Do you know the value of E1? Yes. Do you know the value of E2? Yes. Put all the values and get the value of E3. So, by solving this particular question, you got to know that this sort of a question is not to be solved with the help of E values. This sort of a question is to be solved with the help of delta G. Because your Gibbs free energy is extensive, you can add or subtract extensive properties, but you cannot add or subtract the intensive properties. Your E over here is intensive. I hope I am clear to everyone? I hope I'm clear to everyone. Right? Okay. Can you give this question a try? Can you give this question a try? First of all, I'll write the net reaction. Net reaction, I believe you can easily write now. It will be zinc solid plus copper dye positive aqueous. It gives zinc dye positive aqueous plus copper solid. This is my net reaction, whose N value we already know, that's 2. N value is 2. And if you want to write the QC expression, you can do that. It's concentration of zinc dye positive raised power 1, concentration of Cu dye positive raised power 1. This is QC. Now, as per the question, the concentration of zinc dye positive is 10 times the concentration of Cu dye positive. So the concentration of zinc dye positive is equal to 10 times the concentration of Cu dye positive. It's given. It's given. So zinc dye positive divided by Cu dye positive, that's 10. So this term is equal to 10. This term is equal to 10 basically. Correct? This term is equal to 10. This divided by this is equal to 10. Perfect. We have to calculate delta G. What is delta G all about? Delta G is equal to minus NF E cell. Minus NF E cell. Delta G is equal to minus NF E cell. So first of all, I'll calculate E cell. How do I calculate E cell? E cell is equal to E naught cell, which has to be given 1.1 minus. If I use this equation, 2.303 RT divided by NF. RT divided by NF. What is N value? What is N value? N value is 2. So it's NF log of QC. QC is 10. So log of 10 is 1. So this is my E cell value. This is my E cell value. I got the E cell value. Now delta G is equal to minus N value is how much? N value is 2 minus NF. What is E cell? E cell is 1.1. E cell is 1.1. Just a second. This is N is 2. This is N is 2. This is F. E cell is 1.1 minus 2.303 RT divided by 2F. Correct? Bit of calculation is needed. It will be minus 2.2F minus plus 2F cancelled. So this is 2.303 RT. So if you look at the final answer, right, your final answer is given in this format on 2.303 minus 2.2F. 2.303 RT minus 2.2F. Is it clear? Is it clear? Is it clear? Someone is saying 1 by 10. Where 1 by 10? Concentration of zinc dye positive is 10 times the concentration of Cu dye positive. Concentration of zinc dye positive is 10 times the concentration of Cu dye positive. So zinc dye positive divided by Cu dye positive is equal to 10. Right? There's nothing, guys, here. It's a simpler one. It is a simpler one. Correct answer is option C. Right? Okay. Maybe in this particular question, you can do a mistake. Maybe in this question. We are given with a reaction 4 by 3 times aluminium plus O2. It gives 2 by 3 times Al2O3. Delta G is given minus 827 kilojoules, right? The minimum EMF required to carry out the electrolysis. So E is to be calculated. E is to be calculated. You know, your delta G is equal to minus NFE. Minus NFE. Perfect. E is to be calculated. So E has to be equal to minus times delta G divided by NF. What is delta G? Delta G is given in terms of kilojoules. Okay, so that is minus 827. Minus becomes plus, right? So it becomes plus 827 000 joules divided by N value will be calculating. Faraday's constant is 96500. Now we have to get the value of N first of all. What is N? N is not the N factor here. N is number of moles of electrons exchanged in this reaction. See guys, this is 0 here. This is plus 3. 0 to plus 3 changes 3. Right? Changes 3. Perfect. That means 1 mole of aluminium is losing 3 moles of electrons. if 1 mole of aluminium is losing 3 moles of electrons. Therefore, 4 by 3 moles of aluminium will be losing 4 by 3 multiplied by 3, which will be 4 moles of electrons. Right? So N value you got directly as 4. N value directly you got as 4. If N is 4, put the value here. So E will be 827,000 divided by N is 4 multiplied by 96500. Do this calculation and get the answer in volts. Right? Perfect. I hope this sort of a question, again, you can solve from now on. Look at this question. Look at this question. Look at this question. The pressure of H2 required to make the potential of hydrogen 0 in pure water. Right? The language looks complicated, right? Language looks complicated. So basically you are given with the hydrogen electrode. Just have a look. Basically, this is your solution containing your H positive ions, right? This is the solution containing H positive ions. This is your hydrogen electrode. This is your hydrogen electrode. And how this hydrogen electrode is made, you know it. We take platinum, we introduce H2 gas, right? We introduce H2 gas on that platinum rod. Perfect. Now guys, as per the question is concerned, this rod is there in the pure water. This rod is there in the pure water. If the rod is in the pure water, for pure water at 25 degrees centigrade, you know pH is 7. If it is pure water in the container, its pH has to be 7 at 25 degrees centigrade, right? So what will be the concentration of H positive in the container? Has to be 10 raised power minus 7 molar. Number 1. Let's say the pressure of H2, right? Pressure of H2, we need to calculate. Now, as per the question, the pressure of H2 required to make the potential, it is not mentioned whether oxidation potential or reduction potential. So I have to take it as the reduction potential. What has to be the pressure of H2 gas? What has to be the pressure of H2 gas such that the reduction potential of this electrode becomes 0? Becomes 0. Right? So, what has to be the pressure of H2 gas such that reduction potential of this electrode becomes 0? So I'll make sure, first of all, this electrode behaves like the cathode because at cathode only reduction happens. And when hydrogen electrode behaves like cathode, this is the reaction. This is the reaction. What about its QC? QC is pressure of H2 raised power stoichiometric coefficient, concentration of H2, concentration of H positive raised power 2. Concentration of H positive is 10 raised power minus 7, which makes it 10 raised power minus 14. This is QC. Now, as per the Nernst equation, reduction potential is equal to E naught RED minus 0.0591 divided by N and its log of QC. You know it. As per the question, we have to make the reduction potential of hydrogen electrode 0. SRP of hydrogen is already 0. So this is 0, this is 0. This is 0, this is 0. Right? Perfect. Perfect, guys. If this is 0, this is also 0. So I'll get something like 0.0591 divided by N log of QC. Log of QC has to be 0. When can be this term 0? This term can be 0 if QC is 1. This term can be 0 if QC is 1 because then only log of 1 becomes 0. This whole term becomes 0. QC1 means partial pressure of H2 divided by 10 raised power minus 4 has to be 1. So partial pressure of H2 I am keeping as 10 raised power minus 14 atm. Right? So pressure of H2 has to be 10 raised power minus 14 atm. Then only the electrode potential of this hydrogen electrode will come out to be 0. Right? I believe it's clear. I believe it's clear. I believe it's clear. Look at this question. Look at this question. A zinc electrode, basically a zinc rod, is dipped in a 0.1 molar solution of its salt at 25 degrees centigrade. Assume the electrolyte is 20% dissociated. Assume the electrolyte is 20% dissociated. Calculate the electrode potential. Electrode potential means reduction potential, right? Calculate the reduction potential. See what the question is. See what the question is. My dear students, as per the question is concerned, you have taken a container. This is the container. In this container, you have taken salt of a zinc. Salt of zinc. For example, you have taken zinc sulfate. How zinc sulfate undergoes dissociation? Zinc di positive plus SO4 di negative. Number one. Number one. Number one. In this particular container, you have introduced zinc rod. You have introduced zinc rod. Okay. As per the question, the concentration of zinc sulfate initially is 0.1 molar. It is 0.1 molar. So this will be 0 initially, this will be 0. As per the question, they are asking you to calculate the reduction potential of this electrode. To calculate the reduction potential of this electrode when 20% electrolyte would have got dissociated. Calculate the reduction potential of the electrode when 20% this electrolyte would have got dissociated. So tell me, when 20% electrolyte would have got dissociated. 20%. 20% of 0.1 is 0.02. 20% of 0.1 is 0.02. So out of 0.1, I'll be left with this much. This is the concentration of zinc sulfate when 20% of the electrolyte is dissociated. Now, 1 mole gives 1 mole. 0.02 would have given 0.02. 1 gives 1. 0.02 gives 0.02. So, I got to know the concentration of zinc di-positives and concentration of SO4 di-negatives when 20% electrolyte would have got dissociated. When 20% electrolyte would have got dissociated. That's what I wanted. That's what I wanted. I first of all calculated when 20% electrolyte is dissociated, what will be the concentration of ions in the container. I got that. Now, when zinc electrode undergoes, what do I have to calculate? Reduction potential. If I need to calculate reduction potential, I'll make sure this electrode behaves like the cathode, and at cathode reduction takes place. So the reaction has to be zinc di-positive aqueous plus 2 electrons. Gives what? Gives zinc solid, right? Gives zinc solid. So what is N value here? 2. What about QC? QC would be 1 divided by concentration of zinc di-positive. Which concentration of zinc di-positive I need to take here? 0.02. The value comes out to be 50. The value comes out to be 50. Now, use the Nernst equation. ERED is equal to E naught RED minus 0.0591 divided by N. Then it's going to be log of QC. All the parameters are given. Standard reduction potential here is given. N value you have already calculated. QC you have calculated. So you can calculate the reduction potential of this half cell when 20% electrolyte would have got dissociated. Yes? Right, people? Is it clear? This should be clear to everyone again. This should be clear to everyone. Let's have a look on this particular question. Well, for this particular question, have you studied ionic equilibrium sometimes? Have you studied ionic equilibrium? Because this question I can only solve if you know certain things about ionic equilibrium. Have you ever studied that? I'm going to teach that after in week 2. But tell me that. Have you studied it ever? Have you studied ionic equilibrium ever? Yeah? Okay, see what the question is, guys. We are given with the electrode. This is your electrode. This is your electrode. pH is given. Temperature is given. E naught value is given. What do we need to calculate? Reduction potential of this electrode. Reduction potential of this electrode. In order to get the reduction potential of this electrode, we'll have to make sure that this electrode behaves like the cathode so that we can write the reduction reaction. Right? So, what will be the reaction? Al tri-positive. The reaction has to be Al tri-positive aqueous plus 3 electrons. It should give Al solid. This has to be the reaction. Okay? First of all, you got the N value. N value is how much? N value is 3. N value is 3. Okay? QC. I need to calculate reduction potential. So I have to use Nernst equation at the end. Okay? QC. What is QC? 1 divided by concentration of Al tri-positive. Okay? 1 divided by concentration of Al tri-positive. That's QC. Well, is the concentration of Al tri-positive given anywhere? It's not given anywhere. Right? Concentration of Al tri-positive. It is not given anywhere. So we have to calculate the concentration of Al tri-positive. From where I'm going to calculate the concentration of Al tri-positive. My dear students, pH of the solution. pH of the solution is given to us. pH of the solution is given to us as 12. Temperature is 298 Kelvin, 25 degrees centigrade. You must be knowing at 25 degrees centigrade, pH plus POH is equal to 14, right? So from here, can I calculate POH? 14 minus 2, 14 minus 12, that's 2. If you got POH, can't I calculate OH negative concentration? 10 raised power minus 2 molar, right? I got OH negative concentration, but what do I need? I need Al tri positive concentration. I need Al tri positive concentration. Now, as per the equation, solubility product of AlOH whole thrice, OL whole thrice, how it would have undergone dissociation? Al tri positive plus 3 times OH negative, right? If you write its solubility product expression, it will be concentration of Al tri positive raised power 1, concentration of OH negative raised power 3. Solubility product is given 10 raised power minus 36 is equal concentration of Al tri positive. OH negative concentration is 10 raised power minus 2 ka cube is 10 raised power minus 6. So from here, you got to know concentration of Al tri positive is 10 raised power minus 30 molar. Did you understand how exactly I got the concentration of Al tri positive? If you got the concentration of Al tri positive, so QC will be 10 raised power 30. QC is 30. N already calculated. Now you can use the Nernst equation since you have to calculate reduction potential is equal to E naught RAD. E naught RAD. Standard reduction potential is given minus 1.66 minus 0.05 91 divided by N, that is 3 log of QC. QC is 10 raised power 30, right? So it's going to be minus 1.66 minus 0.0591 divided by 3 log of M raised power N is N log M. So 30 log 10 is 1. Solve it, get the answer in volts. Am I clear? Am I clear, people? Am I clear? Got it? This sort of equation you can solve. Chalo, one question which all of you must be knowing. In the yesterday session, we have discussed it. Tell me the answer of this question. You are not supposed to use a pen and paper here. You are not supposed to use pen and paper here. What do you think about this question? Quickly. Quickly, guys. Till then, I'll sit. Quick. Quickly, people. Done? Is it done? Absolutely, it's option C. Discussed in detail when you do the aqueous electrolysis of aqueous copper sulfate, products of electrolysis. O2 gets liberated at anode and copper gets deposited at cathode. Discuss this in detail. Tell me the answer of this question. Tell me the answer of this particular question. How much charge is required for the reduction of? It's simple, guys. You have to convert 1 mole of zinc into 1 mole of zinc dipositive into zinc, right? Perfect. So in order to, as per this reaction, in order to convert 1 mole of zinc dipositive into zinc, how many moles of electrons are required? Let's say 2 moles of electrons are required. 2 mole electrons are required, right? Charge on 1 mole electron is equal to 1 farad. So charge on 2 mole electrons will be 2 farad, which will be 2 multiplied by 96500 coulombs. This is the answer. So for the reduction of 1 mole of zinc dipositive into zinc, this much coulomb of charge is required. Yes? Done? It has to be option A. How do you think we should solve this question? Again, a simple basic question. The number of farads required to produce 20 grams of calcium. To produce 20 grams of calcium from molten CaCl2. First of all, how calcium would get deposited? You should think over it. Basically, in the solution, there will be Ca dipositives. They'll go to cathode. They'll take 2 electrons and will get converted into calcium solid. And this calcium solid will get deposited. And this is something which will happen at cathode. because at cathode only reduction will happen, gain of electrons will happen, right? So in the solution, calcium dipositive will gain 2 electrons, will get converted into calcium solid, right? Perfect. Now, as per the question, how many grams of calcium are supposed to be deposited? 20 grams. So if I say, as per Faraday's law, mass of calcium deposited is equal to equivalent mass of calcium multiplied by I multiplied by T divided by 96500. Something which you all would have discussed. Yesterday we discussed. What is the mass of calcium which has to be deposited? 20 grams is equal to equivalent mass of calcium. Molar mass of calcium divided by n factor of calcium. What is n factor of calcium? It is 2 divided by 1. That's 2. In the denominator, 96500. I multiplied by T is something which you call as charge, represented by Q, right? Represented by Q. 2, 1, 2, 20. 20, 20, cancel. So charge came out to be 96500 coulombs, which is what you call as 1 farad. Which you call as 1 farad. Am I clear? Am I clear, people? Look at one more question. Look at one more question. A solution of NiNO3 twice, right, is electrolyzed between platinum electrodes using 0.1 farad electrodes. How many moles of nickel will be deposited? How many moles of nickel will be deposited? What do you think? What do you think? Can you tell me first of all the oxidation state of nickel here? Can you tell me the charge on nickel here quickly? What do you think? What do you think will be the charge on nickel quickly? What do you think will be the charge on nickel? It will be Ni di positive basically. It will be Ni di positive, right? Crisscross. 2 goes here, 1 goes here. It is Ni di. So in the solution, you have got nickel dipositive ions. Now, the question says nickel is getting deposited basically. Nickel is getting deposited. How nickel would be getting deposited? You must be knowing it now. Nickel dipositive will be gaining 2 electrons and will be getting converted into nickel solid. Perfect. How many moles of electrons? 2 moles of electrons. Okay. 2 moles of electrons. Well, I do not have to do anything with the moles of electrons though. Okay. As per the question, nickel is getting deposited, right? How much charge is going in the solution? 0.1 farad charge is going into the solution. That means 9650 coulombs are going into the solution. How many moles of nickel would be deposited at cathode? Number of moles of nickel deposited is equal to I multiplied by T divided by n factor of nickel multiplied by 96500. How many moles of nickel? Okay, that's something which you are supposed to calculate. Is equal to I multiplied by T is charge Q, which is 9650, right? N factor of nickel is 2 divided by 1. That's 2 multiplied by 96500. So this is 1, this is 10. So 1 by 10, which is 0.1. 0.1 moles of nickel will be getting deposited at the cathode during this electrolysis. Yes, Sandeep, you can do that. Am I clear? Am I clear, people? Am I clear with this? Quickly. One again very simple question. Can you solve this? Can you solve this? Can you solve this particular question quickly? Was it 1 by 10 or 1 by 20? People are saying I did some calculation mistake. Where is that calculation mistake? Okay, this is 2 times 20. All right. This is 1 by 20. 1 by 20 means 0.2. So the answer has to be this one. Okay. Tell me quickly the answer of this particular question. As per the question, you are converting MnO4 di-negative. You're oxidizing it to what? To MnO4 negative. This is the process. This is the process, right? First of all, manganese oxidation state here is +6. Here it's +7. So +6 to +7 increase. Increase means oxidation. So it is losing 1 electron. It's losing 1 electron. Okay. Now, can I say when 1 mole MnO4 di-negative undergoes oxidation through this process? 1 mole electron is lost. Charge on 1 mole electron is 1 farad, right? So when 1 mole MnO4 dinegative is oxidized, this much charge is required. As per the question, we have to oxidize 0.1 moles of MnO4. So when 0.1 mole MnO4 dinegative is to be oxidized, right? The charge required will be 0.1 farads. 0.1 and 1 farad is 96500. The value comes out to be 9650 coulomb. So this much charge is required basically for the oxidation of 0.1 moles of MnO4 dinegative to MnO4 negative. Okay? Done? Done, people? Tell me the answer of this particular question. What do you think? Faraday's second law. It is related to what? Gram equivalence? Equivalent weights? It's related to what? We have discussed this. You should be knowing it now. We have discussed it. If same quantity of electricity is passed through the solution of copper sulfate and AgNO3 connected in a series, the equivalence of copper and silver deposit has to be the same. This is the statement, right? This is the statement of Faraday's second law. Okay? Solve this one. Solve this one, people. Solve this one. The molar conductivity of AgNO3 solution with electrolytic conductivity as this much. So conductivity value is given as Simon centimeter inverse. What do you need to calculate? We need molar conductivity. Molar conductivity, you know, it is kappa multiplied by 1000 divided by molarity when you have to get the value of molar conductivity in Simon centimeter square per mole. So lambda m, it's a matter of calculation only. This is 5.76 multiplied by 1000 and concentration is 0.5. Solve this, get the answer. Right? Simple and basic question. Simple and basic question this is. Tell me the answer of this one. What do you think? Which of the following solutions will have highest value of molar conductance? Highest value of molar conductance. What do you think? How you are going to use your brain here? How you guys are going to use your brain here? See guys, first of all, CH3COH, it's a weak electrolyte. It's a weak electrolyte. It is a weak electrolyte. No matter what, weak electrolyte as well as strong electrolyte. With dilution, their molar conductance increases. With dilution, molar conductance increases. With dilution, molar conductance increases. Okay? With dilution, what happens to concentration? Volume increases, concentration decreases, right? With dilution, concentration decreases basically. I can say, with the decrease in concentration of the weak electrolyte, molar conductance increases. So, where do you see the concentration least? 1 molar, 0.5 molar, 0.3 molar. Concentration is least here. Least concentration means maximum molar conductivity. It has to be option D. It has to be option D. Right? It has to be option D. It has to be option D. This question again can be solved, I believe. Resistance of one normal solution of acetic acid is given. Cell constant is given. Equivalent conductance we have to calculate. We have to calculate lambda EQ in Simon centimeter square per equivalent. So formula I will have to use conductivity multiplied by 1000 divided by normality. Simon centimeter square per equivalent. This is the formula. Now, normality is given. Normality is given. How do you calculate this conductivity? Conductivity is nothing. It is 1 divided by R multiplied by cell constant. Right? So conductivity is equal to 1 divided by R. R is the resistance, 250 ohm. Cell constant is given as 1.15. So when you solve this, you'll get the conductivity, which will be in Simon centimeter inverse. Okay, and once you get the conductivity, so lambda EQ has to be equal conductivity, which is 1 upon 250 multiplied by what? Multiplied by 1.15 multiplied by this 1000 divided by normality. Normality is given as 1. So this will be Simon centimeter square per equivalent. Matter of calculation, it is 1150 divided by 250. How much that comes out to be? 4 point something, right? 4 point something. It's option A. Correct? Has to be A. One basic question. I think this is something which all of you would be solving on your own. First of all, tell me how this Al2SO4 whole thrice will undergo dissociation. It will be 2 times Al tri positive plus 3 times SO4 dinegative. Right? So, what do you have to calculate? If I use the Cole-Ross law, molar conductivity at infinite dilution of Al2SO4 whole thrice is equal to 2 times the molar conductivity of what? Al tri positive plus 3 times the molar conductivity of what? SO4 dinegative as infinite dilution. At infinite dilution. Now, this particular term is given to us as 858 Simon centimeter square per mole, 2 times Al tri positive. We need to calculate. Plus 3 times. For SO4 dinegative, it's given. How much? 160. 3 times 160. Again, one equation, one unknown. You'll be getting the molar conductivity at infinite dilution of what? Al tri positive here. Okay? I hope I'm clear. Right? Give this question a try. Give this question a try. We are given with ammonium hydroxide. Right? As per the question, when its concentration is kept as 0.1 molar, its molar conductivity. It's molar conductivity, or you can call it as molar conductance. When concentration is kept 0.1 molar, its molar conductivity has been kept as 9.54 Simon centimeter square per mole, right? And at infinite dilution, its molar conductivity is also given. How much? 238 Simon centimeter square per mole. What do we have to calculate? Degree of dissociation of ammonium hydroxide. Guys, do you remember yesterday I told you degree of dissociation is equal to molar conductivity at a given concentration, molar conductivity at infinite dilution, right? So it is simple. 9.54 divided by 238. 9.54 divided by 238, right? Okay. So when you solve this, degree of dissociation will come out to be 0.04 approximately. This degree of dissociation. But over here, the answer is in terms of percentage dissociation. So percentage dissociation has to be equal. This multiplied by 100, which comes out to be approximately 4, right? So 4% NH4OH has been basically dissociated into its ion, right? Perfect. 4% NH4OH has been dissociated into its ions. Right, people? Perfect. I hope this is clear. I'm checking those sort of questions which we have not solved. Rest all the patterns, they are absolutely same only. Can you solve this one? Can you solve this one? Can you solve this one? And guys, whatever questions we have done in your NEET examination, nothing will be asked apart from these, right? Just remember it. Nothing will be asked apart from all these. We have to calculate the equilibrium constant. If we have to calculate the equilibrium constant, that means the cell has to be at equilibrium. If the cell has to be at equilibrium, E cell will be 0. N value for this reaction will be 2, right? So I'll use the expression E naught cell is equal to 0.0591 divided by 2 log of equilibrium constant. This equilibrium constant we have to calculate. E naught cell is how much? 0.46. 0.46 into 2 is 0.92. 0.92 divided by 0.0591 is equal to log of KEQ. How much this value comes out be? How much this value comes out be? Can you check it out? Can you check it out, guys? This value approximately will be 15.6. So log of KEQ is equal to 15.6, or I can say KEQ is equal to NT log of 15.6. How do you calculate NT log of 15.6? I'll break it in two parts, 15 plus 0.6. 15 plus 0.6. This 15 I'll directly write as 10 raised power 15. 0.6 is log of 2. So 2 into 10 raised power 15 will be approximate answer. Is there any option like that? Sorry. This is 0.6 is log of 4. So 4 in 10 raised power 15 will be approximate answer. Okay? It has to be option C now. Perfect. Telegram ID already I have given you. Somebody is asking about the Telegram ID, that's already given. t.me/WASSIMSIRCHEM. Can you solve this one? Can you check it out? Can you check this question out? Can you check this question out? Can you check this question out quick? A reaction is given. Some data is given. One thing which you can see over here. One thing which you can see over here. pH is given as X. Partial pressure of O2 is given. This is also given. Okay. First thing if I ask you, since we are given with a reaction, can we calculate QC for the reaction? Start with concentration of Fe di positive raised power 2 divided by solid. This will be partial pressure of O2 and this will be concentration of H positive raised power 4. Okay. This is something which is given to us. Now, as per the question, look at this particular parameter. E cell is equal to E naught cell. Tell me, think over it. When can E cell be equal to E naught cell? When can be E cell equal to E naught cell? E cell can be equal to E naught cell if QC is equal to 1. Then only log of 1 becomes 0. And as per Nernst equation, E cell will be equal to E naught cell. What is QC here? QC is this term. So this term basically has to be equal to 1. Concentration of Fe di positive as per the question is given. 10 raised power minus 3. Cos square is 10 raised power minus 6 divided by. Partial pressure of O2 is 10 raised power minus 2. Okay. Concentration of H positive. Since pH is X, if pH is X, that means concentration of H positive will be 10 raised power minus X mole. Right? So this is 10 raised power minus X raised power 4. So 10 raised power minus 4X is equal to 1. So it will be 10 raised power minus 4 divided by 10 raised power minus 4X is equal to 1. So from here you can say 10 raised power minus 4X is equal to 10 raised power minus 4, which is only possible if X value is equal to 1. And this is X which I was supposed to calculate. Right? X is I was supposed to calculate. And what is X? X is basically the pH of the solution. So pH of the solution you got to know indirectly as 1. These are all the similar questions. Check this one. Try this one out quickly. Guys, try this one out. Try this one out quickly. Done? Done, guys? The time required to liberate these many moles of H2 gas. For the liberation of H2 gas, you can write the simple reaction. 2 times H positive. You can write this reaction as well. Completely fine, right? So first of all, what is the N factor of H2 here? 2 by 1, that's 2. Number of moles of H2 liberated is equal to I multiplied by T divided by N factor of H2 multiplied by 96500, right? As per the question, how many moles of H2 are supposed to be liberated? 0.01. So 0.01 moles of H2 are supposed to be liberated is equal to. Our current is 10 milliamperes. So 10 into 10 raised power minus 3. Time. How much time? For how much time it's passing, we have to calculate that, I believe. Right? We have to calculate that time divided by N factor of H2 is 2. Multiplied by what? 96500. This 10 raised power minus 2 and this 10 raised power minus 2 cancelled. So T comes out to be equal to 2 farads. Sorry, 2T comes out to be 2 into this, 2 into 96500, and the answer is going to be in seconds, right? How much it's going to be? How much it is going to be? I think it'll be option 2, right? I think it'll be option 2. What do you think is going to be the answer of this question? We have to calculate limiting molar conductivity of NH4OH. Limiting molar conductivity of NH4OH, Kohl-Ross law. First application of Kohl-Ross law. If you look at the last option, this NH4 positive, Cl negative. This is Na positive, OH negative. This Na positive, Cl negative, right? So you are adding these two, subtracting this one. Perfect. So it is basically like this: NH4 positive plus Cl negative plus Na positive plus OH negative minus Na positive minus Cl negative. Do you see anything cancelling out? Cl cancel. Na positive cancel. So I'll be left with NH4 positive plus OH negative, which will give you the molar conductivity at infinite dilution of NH4OH, right? Right, people? So it has to be option D. No need to think over it. Look at this question. Look at this particular question. Equivalent conductivity of 1 by 32 molar solution of weak monobasic acid. Weak monobasic acid. This is the acid. Weak and it's monobasic. Its equivalent conductivity is given. And at infinite dilution. And at infinite dilution is 400. The dissociation constant of this particular acid will be. The dissociation constant of this particular acid will be. First of all, how this monobasic acid will undergo dissociation? H positive plus A negative. This is how it's undergoing dissociation. If you have studied equilibrium at time t is equal to 0, its concentration, if it is C, this is 0, this is 0. And as per the equation, this C is already given, 1 by 32 molar, right? Now, at equilibrium, this is going to be C minus C alpha. This will be C alpha. This will be C alpha, right? This will be C alpha, C alpha. Perfect. Now, if you write the expression for dissociation constant, it becomes C alpha square divided by 1 minus alpha. It becomes C alpha square divided by 1 minus alpha. So C is already given. C is already given. I need to calculate alpha here. I need to calculate alpha here. Alpha for this weak acid is equal to molar conductivity, a given concentration, molar conductivity at infinite dilution, right? What is the molar conductivity? Since it is a weak monobasic acid. It is weak monobasic. Its n factor is 1. If its n factor is 1, right? If its n factor is 1, so its molar conductivity at a concentration of this much will be 8 only. So this 8 divided by. Molar conductivity at infinite dilution is given to us as 400, right? So this is 1 upon 50. 1 upon 50 means 0.02. Alpha is 0.02. Since you got alpha, C is already given to you, 1 upon 32. Alpha square, 0.02 ka square, whole divided by 1 minus 0.02 comes out to be 0.08, right? Perfect. Right, people? Perfect. Accordingly, you can solve. Accordingly, you can solve. This is 1 minus 0.02. So you have to calculate K from here, and I believe you can easily do that. I believe you can easily do that. Correct? Asha, do you know why did I take the molar conductivity here as 8? In the yesterday session, I gave you one expression, equivalent conductivity is equal to molar conductivity divided by n factor. N factor of this acid is 1. So its molar conductivity, equivalent conductivity are same, right? That's why I took it directly as this much. Okay? All right. And by the way, just I noticed one thing here. I believe you would have studied your ionic equilibrium. If you see alpha is coming out to be less than 0.05. Alpha is coming out to be less than 0.05. And when alpha is less than 0.05, you can neglect alpha in comparison to 1, right? So instead of 1 minus alpha, you can directly write as 1. So this is the final answer. This is the final answer, right? Okay. Alpha is less than 0.05, so you can neglect alpha in comparison to 1. So it will be just C alpha square. It will be just C alpha square, right? And the final answer is going to be this much. Perfect. So your electrochemistry is also done. Your electrochemistry is also done. And guys, I think I'm done. I'm not able to stand now. I'll post the DPP of solution chapter in the Telegram. Okay, please you give it a try. And if any sort of problem comes, let me know. Because I can feel now I'm exhausted, right? I did not sleep also well. Okay. But I believe all the problems, whatever we have discussed, everything is clear. And guys, these two chapters, let me tell you, nothing is going to be asked out of these questions which I showed you. Okay. Yes, I'll share you this PDF also. I'll share you this PDF also. And solution questions I'll be sharing. You need to give them a try. And I'm pretty much sure you can check them. You can easily do them. I'm pretty much sure you can easily do them. PDF I'll be posting in my Telegram. Yesterday's notes already I have shared in the Telegram. You can check it out. RCB or CSK? CSK. Yes, Sandeep, for JEE preparation, you can check that channel for sure. Okay. And tomorrow you have got, guys, do you know, complete class 12th physics marathon 1, right? Do join that at any cost. Yes, I'll share. There'll be answers in the PDF as well. But right after the session, please and please try solution chapter on your own. Huh? Because I got very tired. I'm unable to stand. Actually, 2 back-to-back marathons. It is difficult. You can ask me if you were unable to solve any question. You can ask me on my Telegram. It is WASSIM_BHAT. You can just send it to me. Okay. And let me know in the comment section how exactly did you like the session. Okay. Right after the session, I'm sharing the PDF. Someone is asking how many questions are done. Why do you worry about that? The point is all the problem patterns which can be asked from the chapters, we have covered them. Nothing is going to be asked apart from all these things. Okay. I've shown you all the problem patterns. All are covered. Okay. Hello guys. I'm taking a leave with this. I'll send the PDF right after in the Telegram in like 5-10 minutes. Okay. And do let me know how exactly you like the session in the comment section. Take care. God bless you all. See you in the next session.